Just a minute. Huh? Okay, good morning everyone. I'm really sorry. That is on me actually. Okay, 1 second. Good morning everyone. I'm so sorry for starting late. But let's jump first. Good morning everyone. I'll read your comments, okay? I'll actually answer everyone. Hello, good morning. Okay, class started. I am so sorry. Okay, I would have 1 second. Good morning, Shreyas, Afan. Yes. Josh meter is, yes, I wanted to ask that. How is your Josh? Because we'll be solving so many questions. Okay, just one thing, if I'm correctly focused or not. Yep, I'm in focus, I think. Yeah. So any doubts you have, and I read some of your comments on the way actually. So yes, we will be starting from basics. So if you have any doubts, don't worry. Firstly, I'll give you time to ask your doubts. And second thing, any question that we are doing, we'll be doing from basics. Okay. Yes. Okay. The celebration was really good, and I am proud of all of you for scoring such good marks. Yes, I was actually reading your comments while on the way. Some of you got 80, 85. That's a really good score. Okay. Yes. Good morning, Gooseby. Good morning, Vimal. Good morning, everyone. Okay, so let's start first. Okay, we'll do the greetings later on. Okay, in every question, I want your answer because I think we have solved some of those questions in our previous lives, the 15 days challenge that we were doing. Okay, so now all you have to do is answer with me. Okay, are you ready? How's the Josh, guys? Super high, machas and machis. I am good. Let's start. Okay, so first question is this one. Very easy question. Bond order. We are talking about bond order. It's from chemical bonding. Okay, so yes, it's a PYP, that means a previous year question paper. It's a 2025 previous year question paper for KCET chemistry. Okay, some of the questions we might have solved in our previous classes because we were doing most repeated PYQs. Okay, yes, super high. Let's see the answers now. Coming straight up, what are the answers? Okay, so we need to know the bond order. So I told you one trick, that remember just one. Whenever you have 14 electrons, okay, whenever you have 14 electrons, the bond order will be 3. Whenever you have 14 electrons, the bond order is 3. Who have 14 electrons? Nitrogen, ma'am, N2. It has 14 electrons. What else have 14 electrons? Let's see here. Nitrogen have how many electrons? 7. Oxygen has 8 electrons, so that is 15, right? How many electrons CO have? 6 plus 8, again 14 electrons. O2 negative, is it visible? O2 negative. O2 negative means 16 minus negative. Whenever there is a minus, you plus, you add it, and whenever there is a plus charge, you subtract it. Okay, so whenever there is a minus charge, you add it. Whenever there is a plus charge, you subtract it. And all of you are answering D already. Okay, so plus 1, that means 17 electrons are there. O2 means again 16 electrons. Now, how do you calculate? 14 electrons is 3. The bond order for 14 electrons is 3. Now, even if you go up, that is you decrease the electrons than 14, or you increase the number of electrons, right? You do 13, 12, 11, right? Or you do 15, 16, 17, your bond order will also decrease in both cases. If you increase the number of electrons or you decrease the number of electrons, in both cases your bond order shall decrease by 0.5. Okay, so here 2.5 to 1.5, here 2.5 to 1.5. Simple, right? So 14 electron, we know that the bond order for 14 electron is 3, and if you add or subtract electrons from this 14 electrons, the bond order shall decrease by 0.5. Now see, 14 electrons, that means its bond order is what? 3. So for B we have B is 4, which have B4, B4, B4. That means it's either option. Did I do something wrong? 8, 6, 14. Yes, that is 3. Okay, yeah. So for B, the answer is 4. B, the answer is 4. Now, check for 15 electrons. 15 electrons bond order is what? 2.5. 2.5. That means third option. For A is 3. A, it's 3. So the correct answer is option A. Why are you answering D? So many of you answered D. Good morning, guys. Why? Okay, yeah, A. So the correct answer is A. Why? Because 15 electrons means the bond order is 2.5. 14 electrons means the bond order is 3, right? 17 electrons means the bond order will be 1.5. 1.5. Where is 1.5? So C is 1. And for your 16 electrons, again for your 16 electrons, the bond order shall be 2. The bond order shall be 2. Clear? It's little blur. Okay, no worries. Mohammed, we will answer all of your doubts. Don't worry. Please be ready with your doubts. Once we have we have done 30 questions, then we'll answer your doubts, and then we'll do the next 30 and then answer your doubts. Okay? So is it okay? In between, I can't take your doubts because we are solving questions here. I think it's clearly visible, or is it? Just let me know if it's not clearly visible to you all. It is clearly visible, or is it still blurry? Yes, the marks you got, that depends actually. It's 50-50 from KCET 50 and your PU2 boards also 50%. 50% weightage from there, 50% weightage from there. The class duration, we'll figure it out. It'll be 2-3 hour class, I think, because we are solving 60 questions, not just like in exam. We'll be explaining also from basics. Okay? Okay. Clear? Done. Okay, next question. The electronic configuration for X and Y is given. X have how many electrons? This is the outermost shell, 3s and 3p. So X has 5 valence electrons. Okay, Y has how many? 3s2 and 3p 5. That means it has 7 electrons. 7 electrons. So how many electrons does X needs to complete its octet? 3 electrons, right? And how many electrons are needed by Y to complete its octet? 1 electron, right? Okay, now you need to tell what is the correct molecular formula and the type of bond formed between X and Y. And the type of bond formed between X and Y. Very easy, right? Why? Because you see, ma'am, 5 electrons. That means it is from nitrogen family. Ma'am, 7 electrons. That means it is from halogen family, right? This is from nitrogen family. This is from halogen family. And I know that, ma'am, ki nitrogen only forms covalent bond. Why? Because obviously it's not able to transfer the electrons. It forms covalent bond. So I know one thing, the bond will be covalent. The bond will be covalent, right? Okay, now second thing, ma'am, nitrogen needs 3 electrons and halogen, this X, Y, we have this Y here, this Y needs only 1 electron, so it will form only one bond because it needs only 1 electrons. But this X needs 3 electrons. This X needs 3 electrons. That means, ma'am, there will be 3Y, right? There will be 3Y. So see, ma'am, X is there, okay? X is there, and then this X will form a bond with Y, Y and Y. In this way, all the octet of this Y is complete. Okay, octet of this Y is complete and octet of this Y is complete. Similarly, the octet of this X is also complete. The octet of this X, in between the X we have, right, is also complete. So what is the molecular formula now? X, Y, 3, and the bond is covalent bond, and the bond formed is covalent bond, not that is 1. Okay, C is unique. C is unique. See, they are similar, no? If you are doing that scientific guessing, that is only applicable for a certain amount of questions, not everyone. And for these kind of questions, you can answer them. Okay. What's with the emojis, guys? C. Yes. So everyone answering C. That is correct answer. Clear? Next question. You are given different type of reactions and the examples. You need to match them. Okay. So firstly, combination. No one seems like a combination reaction here. So we'll deal with it later. Decomposition. That means one reactant is decomposing into 2 or more products. So what is here? This is decomposition, right? Decomposition of H2O2 to form H2O plus O2. That is decomposition, right? decomposition. Displacement reaction, I only know one. See, that B is 2. So B is 2 means the correct answer is D, right? Even if you know only one, you can answer that, right? Now displacement means displacement is happening some sort of. So here in your, yes, this is displacement. Chlorine gas is electron donation is going on. Br negative is losing its electron to chlorine, and chlorine gas is getting converted into Cl negative ion, aqueous ion, and Br negative after losing its electron is getting converted into Br2. There is an exchange happening here. Displacement, okay? That is your displacement reaction. Okay, please Vishwanath, stop spamming. Don't do that. No, not scientific guessing. You're just looking at it and it's unique. Okay, Vishwanath, stop spamming, please. Okay. Next is disproportionation reaction. That means where oxidation as well as reduction both are happening for the same compound. Same molecule is undergoing oxidation as well as reduction. So here D is 4, right? Yeah, here. Water molecule is undergoing oxidation as well as reduction. Oxidation as well as reduction. Okay, just let me, okay, 1 second. Only solving, that's good actually. Yo, I'm stressed actually. Why you are doing that? Okay, I'll have to. You're not letting others study, Vishwanath. That is a bad thing. That is a really bad thing. Okay. C, yes. It's so fast. How can I note it a little? Afan, you can do one thing actually. Yes, 50% marks are coming from Baslingappa, but 15% marks are coming from there. Okay. Yeah, next question. So one of you had doubt how to note it. So do one thing. I am sliding back. Take a screenshot. Okay, I'll give you 2 second time. Take a screenshot in that duration. Whatever notes are there. Okay, and then you can make your notes after the class ends. Because bacha, alongside class, I can't give you the time to make notes, right? That won't be possible. That won't be feasible for all of you. Okay. Yes. So I'll slide down. You take a screenshot and then you can use it later on. Okay. This one is clear. The correct answer is option D. Okay, next question. In which of the following pairs the transition metal are colorless? So for colorless, what conditions we have? For colorless, we have only two conditions. Either it should have D0 or either it should have D10. If there is no D electrons, or if there is completely filled D subcell, or if there is completely filled D orbital, only these two conditions. Either there is no electron in the D orbital or there are 10 electrons completely filled D orbital. Okay, because in both cases D-D transition cannot happen. You know, bacha, what is the reason for color in case of transition metal? The color reason is due to D to D transition. D to D transition, that means from ground state D orbital to an excited state D orbital, electrons are transferring. Electrons we have, the transfer of electrons is happening, right? And because of that transfer, what happens? Color is absorbed. Like when this transition happens, it absorbs a wavelength and then emits something. That is how you see the color. If this doesn't happen, this transition, D to D transition doesn't happen, then that particular metal is colorless. Then that particular metal or metal ion is colorless. Okay, clear, I think. Okay, so in this case, which have this configuration? Let's check that. Okay, scandium 3 positive. Scandium 3 positive. Ma'am, scandium is this, right? 3D1. I am not writing the noble gas part. Argon is there. Okay. After that, 3D1, 4s2. And if we are having scandium 3 positive, that means it is 3D0, right? 3D0. Okay. What about zinc? Zinc is 3D10, 4s2. 3D10, 4s2. And zinc 2 positive will have what configuration? These 2 electrons are gone, right? So that is 3D10. So ma'am, we already found it, right? We already found it. 3D0 and D10, D0 and D10. So that means our correct answer is option A. Again, V2 positive, not completely empty. Scandium, titanium, vanadium. That means vanadium has what? 3d3, 4s2. And if we have vanadium 2 positive, that means only these 2 electrons are gone. 3d3. We have electrons in D which can get excited to the higher excited state, which can get excited to the higher excited state, and color transition can happen. Yes, it's SC. Ruko. Okay, everyone, so all of you answered A, which is correct, and you can write it down. Okay, for yes, condition for colorless, you can say this is the condition in case of transition metal. Okay, 1, 2, done. Okay, next question. In this reaction between hydrogen sulfide plus acidified permanganate, what happens? It is a redox reaction, first of all. Second, I don't know. Okay, let's assume I don't know, because obviously I can't remember all the reactions all the time. But I do know one thing, that what the option are telling me, that a redox reaction is happening. One is getting reduced, one is getting oxidized. Now I just have to put my little brain towards think that this MnO4 negative, this is MnO4 negative, right? What is the oxidation state of manganese is in this? The oxidation state is +7. +7. Now for manganese, I know the highest oxidation state possible is +7. For manganese, the highest possible oxidation state is +7. Now if +7 is its highest possible oxidation state, can we increase it then +7? No, that is the highest. Okay, so what we can do? We can decrease it. Decrease it means, ma'am, we will add electrons to it. We will add electrons, and this adding of electrons is called what? Reduction. This adding of electrons is called reduction. That means MnO4 negative is getting reduced. MnO4 negative is getting reduced. And remember this, MnO4 negative gets reduced to what? It always gets reduced to Mn2 positive. From +7 to +2. That means it gains 5 electrons. It gains 5 electrons. Okay, so MnO4 negative gets reduced to Mn2 positive, right? This much I know. Now I can check the options once. MnO4 negative oxidized, wrong. MnO4 negative reduced, MnO2, nope, not happening. MnO4 negative is reduced to Mn2 positive. Yes, that is my correct answer. Okay, even if I do not know half of the reaction, by using like smart way of, you know, or common sense, you can say, little bit of chemistry knowledge also, I can predict it. Okay. How to make reaction from question depends on the question, Kani. From here you do not have to write the exact reaction. You just have to have an idea how MnO4 negative reacts. And what I have seen in the previous papers, they do not want you the exact reaction. They only want you to have an idea of what will happen to MnO4 negative, what will happen to H2S. In this case, I don't know what will happen to H2S, but now I know that H2S will get oxidized to sulfur. H2S will get oxidized to sulfur, and MnO4 negative will get reduced to Mn2 positive. Clear? So it's D, not A. All of you are answering A. Why? Okay, D. Clear? Okay, done. So just take a screenshot, okay? Or if you want the exact reaction, I can write that also. So it's this reaction, 5H2S, okay, plus 2 MnO4 negative, 2 MnO4 negative gives 5 sulfur plus 2 Mn2 positive plus, how many H2O we have? 8 H2O. This is getting reduced and this is getting oxidized. Okay, I hope it is clear. Again, take a screenshot for you making your notes. 1, 2 seconds, done. Okay, because A is the first alphabet, all want first. I think so. No. Some questions, sometimes you can guess a pattern or something. It's okay. Next question. A member of the Lanthanoid series, which is well known for its +4 oxidation state. +4. So we don't know lot of member of Lanthanoid series, obviously. Why? Because it's so typical, plus it's man-made. We humans made that complete series. We developed all the chemicals, all the elements that are there. We developed it synthetically, artificially. Okay, so we gave the name on our own, at our own convenience. Okay, so in this one, just remember that this one has +3. Which has +3? Yes, erbium. This has +3 oxidation state. These have +2, +2. And for cerium, okay, it doesn't have cerium does not only have +4, it also have +2. Okay, cerium has 2 oxidation state, +2 as well as +4. Okay, +2 as well as +4. Now D, yes, the correct answer is D. An additional point for you guys, just listen. Cerium has a +4 oxidation state. Okay, if we have cerium +4, if we have this compound cerium +4, we have this, right? What it will act as, oxidizing agent or reducing agent? Think about it. Will it act as oxidizing agent and reducing agent? Don't panic. What it can do, it can get converted into Ce +2, right? That means, ma'am, it will add electrons. Adding electrons means reduction. Reduction means, what is it? It is a oxidizing agent. It is a oxidizing agent. Clear? So, because Ce +4, cerium +4, it is the highest oxidation state cerium can have. It can only decrease itself to +2. And how it will decrease? It will decrease by adding electrons, and addition of electrons is reduction. And if it is undergoing reduction, that means it's a very good oxidizing agent. Yes, correct, Vijay. It's a very good oxidizing agent. Done? Okay, clear? So yes, the correct answer is option 4, option D. Okay, and it is a very good oxidizing agent. You can write it somewhere. It's a good, this one, cerium +4, not cerium +2. In this case, it will be a reducing agent. It can go up to cerium +4. But if it is cerium +4, it can decrease to cerium +2. In this case, it is a good oxidizing agent. Okay, 1, 2 again. Okay, so sole entity, if you have, my advice will be this. For now, you have KCET coming, so focus on KCET. But if you have your percentage 85% or greater than 85%, your aggregate is 85 and or greater than 85, then don't write. Then don't write. Then don't give your time there, because you already have the knowledge. You already have it. Okay, so you just have to practice it for the exams. Okay, that is there. That is just my advice. Okay, if you have 85, then you should not focus for the second one, because you don't know the level there. Okay, you don't know if you are spending money and you are spending your time there also. Okay, so just that one. But if you have less than that, then you can consider it. Okay, I hope it's clear. Now, in which of the following both the elements do not have, see, the configuration is N-1 D10 and N is 2. So I know, okay, do you know? Do you know? You don't know, but you know that zinc. What is the electronic configuration of zinc? Argon, 3D10, 4s2. 3D10, 4s2. So wherever zinc is, it will have this configuration. But we are looking for the pair which do not have this configuration. Which do not have this configuration. So that means this is not the correct answer. This is not the correct answer also. Now, in here, cadmium, mercury and silver and copper. Okay, just remember one thing. Zinc, cadmium, mercury. Zinc, cadmium, mercury. These three belong to the same group. They all belong to the same group. Okay, so whatever be the electronic configuration for zinc, same will be for cadmium, but again in the next 3D jagah it will be 4D and 5s, then 6D and 4D, here it will be 4D and 5s, here it will be 5D and 6s, okay, for mercury. So the configuration, why? Because obviously zinc, cadmium, mercury belong to the same group. But still, if you do not know that, still you eliminated two answers on the basis of that, right? But you know copper also, right? What is the configuration for copper? Argon. For copper, the configuration is argon. 3D10, 4s1. So that is, yeah, that is not this configuration, right? 3D10, 4s2, N-1D10, NS2. Obviously, so that might be your answer. Right? Even if you do not know this fact, you can still answer. Okay? Look at the brighter side. Don't go dull if you don't know everything about a question, because no one knows that. Even I don't know for some questions. So yes, the correct answer is option D. We directly write third exam, ma'am. No, Vijay, don't wait for third. You know that first has happened. The second exam date sheet is also released, but you don't know. Do you have the third exam date sheet or any idea or any notice or something? You don't yet, right? So they might happen, they might not happen. So if you are looking for improvement, and you want to write it the second exam. Okay, don't wait for the third one. We don't know if it will happen or not. Okay, whatever surety you have, go on with that, please. Okay. That is what I have. We all teachers were discussing that, so that's what we came up with. Yes, because we don't have an idea, Macha. We don't have it. We don't have the idea yet. So yes. Next question, shall we? Yes. Okay. Next question. Okay, 1 second. Screenshots. Yeah. 1, 2. I hope you have taken it. Done. Next question. A ligand which has two different donor atoms and either of the two ligates with the central atom ion in the complex. What is that ligand? So we have two names. We call one is ambidentate, one is bidentate, but both have two donor atoms. Both have two donor sites. Okay. Ambidentate also and bidentate also. But what is the difference? Bidentate can ligate with, can form bond with can form two bonds with the metal atom at one time, because it has two donor atoms and both can form a bond. But here either of the following, either of the two ligates, that means you have two options, but only, for example, I have two hands, but I only write with my left hand, right? Oh, sorry, right hand. Okay, so that means I am ambiguous. What do you call it? Ambiguous, right? 1 second. Yes. So those kind of ligands are called ambidentate ligand. Ambidentate means they have two donor sites, but they form bond via only one donor site. Okay. Yes. This is a PYQ vegan. What is your name? Vegan. Yes, this is a PYP, which is previous year paper for your KCET 2025 chemistry. Okay, KCET chemistry. Done and dusted. Yeah, good. Vedmox, good. Actually, the syllabus is actually little lesser for your KCET. Some portion is being removed from KCET than your JE. Okay, but one thing I would suggest, yes, you have prepared syllabus, kahin se bhi you have done, that's okay. But solve the questions so that you have an idea what kind of questions are being asked. So solve the questions. For KCET, solve the questions. Focus on the questions. Okay, PYQs are very important. Volume rise, okay. Hello. I think the battery might be little less. I am shouting literally. Okay, Ved. So solve questions and then you'll have an idea of how much knowledge gap you have, or is it sufficient or not. I think it will be sufficient if you have completed your JE syllabus then. Vishwanath is back. Why he is back? Let's start. Okay, next question. Which of the following statements are true about NiCl4? Again, some things I know, some things I don't. What is NiCl4? NiCl4, 2 negative. Okay. What is the oxidation state of nickel here? +2, right? The oxidation state is +2. Nickel has a configuration of what? Nickel has 3D8 and 4s2. So that means nickel +2 will have 3D8 configuration, right? Okay, now let's see here. Complex has tetrahedral geometry. Correct. Yeah, it has tetrahedral geometry. Nickel's coordination number is 2. What is the coordination number of nickel here? 4, right? Nickel is forming bonds with 4 chlorines. The coordination number is 4, right? So this is incorrect. Okay. The complex is sp3 hybridized. Yes, when we have tetrahedral geometry, it will be sp3 hybridized, right? Because for tetrahedral, the geometry is what? sp3. Correct. Okay. High spin complex, yes, because Cl is a weak filled ligand, and weak filled ligand do not form low spin complex, they form high spin complex. What do you mean by high spin, ma'am? So we have this macha, we have this thing. In case of tetrahedral, we have E and T2. E and T2. This is how the d orbitals split. Okay. So when we talk about high spin and low spin, that depends on this. High spin complex do not pair. They do not pair. The next electron, if you want to fill after 3 electrons, the next electron will go straight to the T2. This one. Okay. That is high spin. The electrons spin. Spin means electrons. Electrons are there in high orbitals, high spin. Low spin means something that will pair it. Something that will pair it. So instead of going the electron there, the next electron will just pair here. Usse next electron will just pair here. Okay. So that is you call low spin complex. That is low spin complex. Okay, and low spin complex are formed by what? Strong filled ligand. They are formed by strong filled ligand. Okay, just a little criteria I can tell you. So we have, this is the tetrahedral, but I'm telling you the octahedral one. It works for both. So if you have, this is crystal filled splitting energy. What is this crystal filled splitting energy? This energy, the energy gap between this T2 and E. This gap, this is your crystal filled splitting energy. Okay, so this crystal filled splitting energy is less than the pairing energy. P is the pairing energy. If this crystal filled splitting energy is less than your pairing energy, so what happens in chemistry? In chemistry, whenever there is a less energy pathway, or for us also, if we have a shortcut, we'll follow that, right? We won't take the long cut, right? Hard way, we prefer the smart way or easy way over the hard way, right? Similarly here, since this is less, so what happened? The electron, instead of pairing, what it will do? It will go to the higher orbital. It will go to the higher orbital. Cross the energy barrier, go to the higher orbital. Okay, but if the case is opposite, in this case we will get high spin complex. In this case we will get high spin complex. But if this pairing energy, somehow this pairing energy is less than the crystal filled splitting energy. If this pairing energy is less than the crystal filled splitting energy, this is the shortcut for electron, right? So now the electron will do what? It will pair. Instead of going up, instead of going this, like, you know, crossing this distance and going here, the electron will just pair itself there only, right? What will happen here? In this case, we will get low spin complex. Low spin complex. So normally this case is for what? Your strong filled ligand, because strong filled ligands have really high crystal filled splitting energy, right? And this case is for your weak filled ligand. Why? Because weak filled ligand have less crystal filled splitting energy. I hope it is clear, right? This is the basic of it, okay? As basic as you can go, okay? Now let's see here. The complex is paramagnetic. Again, paramagnetic, diamagnetic means, para means single. The electrons are unpaired. Diamagnetic means two. That means the electrons are paired. Okay, so the complex is paramagnetic. Or one more thing, if we are going high spin complex, that means instead of pairing, the electrons are getting shifted to the higher orbital. Instead of pairing, the electrons are getting shifted to the higher orbital. So will it be paramagnetic or diamagnetic? It will be paramagnetic, right? It will be paramagnetic. So you can write here also, they normally make, generally I'm saying, because sometimes you get an exception also. So they make paramagnetic. The substance or the compound will be paramagnetic, and in case of strong filled ligand, as pairing is happening, so whenever pairing is happening, we have diamagnetic complex. Okay, so the correct answer, this is incorrect. It is paramagnetic, correct. High spin complex, correct. sp3 hybridized. So ACDE, which is correct answer, is option A, right? Only B is incorrect. Just take a screenshot, okay? 1, 2, I think. Done? Yes. Okay, next question. Which formula is correct, incorrect? You need to tell the incorrect formula. Okay, so before we go in the incorrect formula, let me give a brief down on how to actually name any coordination compound. So how do you name it? You have a cation. Listen carefully. You have an anion, right? You write the name in a continuation, right? So you don't leave any space. You write it like this. You have a cation. Okay, you have a cation. Firstly, you have the cation part, then you write the anion part, right? And then you have the metal. In the end, you write the metal, and behind that metal, like right after writing the name of the metal, you put the brackets, and in those brackets, you put the oxidation state of that metal. That is the basic rule, right? Now, some other rules are there. For example, if you have an anion, so you add a O at the end. For example, chlorine becomes chlorido, carbonate becomes carbonato, cyanide becomes cyanido. Okay, so it's like that. So add an O in the end of the anion. In case of cation, you just write the name simple as it is. Whatever the name is, potassium, sodium, whatever the cation you have, you just write the name. Okay, so I'll just write here, add O at the end, add O. Clear? Now, after writing this, you have ligands, right? Your ligands can be anion and can be neutral, right? Ligand, because again, we are forming a metal coordinate complex. In that complex, you have cation also, you have neutral ligand also, right? Neutral ligand, how do you name neutral ligand? So, normally 4 are there. You can just write their name. In case of neutral ligands, you have NH3, H2O, CO and NO. So what is the name of them? Only their names are different. In case of anion, you just add a O at the end. Simple. In case of cation, write their normal name. When you have a neutral ligand, you write like this. NH3 becomes amine. Double M-I-N-E, amine. H2O becomes aqua. CO becomes carbonyl. And NO becomes nitrosyl. Okay, one interesting one is there. In anions, you have this NO2, right? NO2. So this can bond from nitrogen side as well as from the oxygen side. So what will you do? If it is binding from the nitrogen side, it's an anion ligand, anionic ligand, okay? So if it is bonding from nitrogen side, you write nitrito N. And if it is bonding from oxygen side, what do you write? You write nitrito O. Okay, nitrito O. These are all the unique ones out there, okay? Rest you will figure out, not much ligands are there. Okay, one important thing, name of metal. There are some rules regarding to the name of metal. That's what the summary of it. But one important rule regarding the name of metal is this. If your metal, you have metal, right? This complex, this metal is a part of the complex. If metal is a part of cationic complex, if metal is a part of the cationic complex or the part of the cation, if metal is a part of the cation, okay, here it is a part of the cation. Firstly you write the cation, then you write the anion, right? So if the metal is a part of the cation, in that case you just write the name of the metal as it is. Metal, regular name is used. Regular name of metal is used, okay? In that case, regular name. If platinum is there, you use platinum. Cobalt is there, you use cobalt. Or if you have chromium is there, you use chromium. But if your metal is a part of anionic complex means instead of where? Okay, so this works for cation as well as neutral ligand. If you have a neutral complex, so for example here we have a neutral complex, no charge on this complex. This is a neutral complex. This is a cationic complex, right? This is a cationic complex. Okay, now if your metal is a part of the anion part, okay, so in that case what will you do? Slight changes there. So whenever you are writing your metal name, at the end you write 8. At the end you write 8. See here the metal is a part of the anion, right? This is cation and the metal is the part of the anion, right? So in that case, just one thing, instead of writing regular name, you add 8 at the end. So chromium becomes chromate, iron becomes ferrate, okay? Platinum becomes platinate. So I'll just write the name ferrate, chromate. Now we have summed up all the rules here. You just need to tell me which of the following is incorrect. Let's start with here. Potassium, correct? Okay. Trioxylato, see O. Anion, at the end of the anion we add an O. Trioxylato, done. And this is a part, this metal is a part of the anionic complex. This is a part of the anionic complex. So what will happen? We'll add a 8. Chromate, and the oxidation state, if you can check, it is +3 only. Don't worry. Okay. Now this one. Again, this is a part of cationic complex. So that means the metal name will remain same. No change in the metal name. We'll start with, we have ethylene diamine. Okay, we have chlorine. So E or C, which comes first? C, right? So we'll start with this one, dichlorido. Oh, one more thing I missed. This di and bis drama. So we have a simple ligand and we have a complex ligand, like ene. This is a complex ligand. So if we have a simple ligand, okay, I'll just write here. If we have a simple ligand, so you use di, tri, tetra, something like this. And if you have a complex ligand, in that case you use bis, tris, tetrakis and all. Okay. Okay. Now, ma'am, while writing the name, do we use this D? You know, alphabetically we are writing. So we use this D, B or something, or their names. So we will only focus on the name of the ligands. Okay. The real name of the ligands. Chlorido and ethylene. So which comes first? C. So we'll write dichlorido first. Dichlorido, and since it is a complex ligand, we'll use bis ethane diamine. ethane 1,2-diamine, okay. And then again cobalt, since it's a part of the cationic complex, and in cation we do not change the name of the metal, cobalt, and the oxidation state is 3, and this is chloride. Again, it's not the part of the complex, it's not the part of the coordination sphere, the chlorine here, so we'll just write chloride, okay. Now let's see here. So that means this is correct. That means this is correct and this is correct also. Now look at here. So again, cationic part. So we'll start with, we have amine and we have carbonate. We have carbonate. So which comes first, amine or carbonate? Amine comes first. So pentamine, carbonyl, wait a second, carbonyl, isn't that incorrect? Because this is carbonate and we'll write carbonato, right? The name should be carbonato. It should not be carbonyl, right? So yes, that is the error. Rest, let's look at the other name. Cobalt 3, that is correct, and chloride. Okay, here the name will be, we have amine, we have chloride, and we have, this is again, the bond is from nitrogen side. So we'll write nitrito N. So which comes first? A comes first, diamine. Okay, there's a mistake here, spelling error also. Double M will be diamine. Okay, then you have chlorido, nitrito N, and then platinum 2. 2 is the oxidation state. I hope the sum, this sums up the IUPAC nomenclature. It's very easy. You need to practice a little bit more, and these are the shortened rules which I sometimes recall I use. Okay, just take a screenshot. Okay, 1, 2, 3, 4, I think. Yes? Okay. Next question. So, how many of you answered option C actually? Yeah. Correct answer is option C. Sorry. Yeah, I know, Satvik, I know, I just corrected it. The M is missing here, okay? That was some typo error or something, but only one correct answer is there, which is C. Next one. In the complex, what is the coordination number of iron? So when you talk about coordination number, what is the formula we use sometimes? So coordination number is the number of ligands that are forming bond with the central metal atom, right? Number of ligands that are forming bond with the central atom, that is coordination. So it's like neighbors. How many houses we have in our proximity, that is which we call our neighbors, which are directly connected to us. They are our neighbors. So coordination number means neighbors. Okay. Now see, coordination number is equals to the number of ligands time its denticity. Now what does this denticity mean? So obviously you are at this stage of your preparation, you already know what denticity means. So denticity means the number of bonds, the number of donor atoms that ligand have that are forming bonds. Having donor atom is not equal to denticity. It can have, again we have ambidentate, right? They can have 2 donor atom but only one is forming bond. So that means denticity is 1. So the donor atoms that are forming bond with the metal atom, the donor atoms that are forming bond with the central atom, that is your denticity. So here this is oxalate. This is oxalate. Now oxalate has a denticity of 2. It has 2 possibilities. This is oxalate. 2 possibilities. It can form bond from both sides at the same time. Okay, it can form bond from both sides at the same time. It's a bidentate ligand. It's a bidentate ligand. So again, what is the number of ligand here? 3 times denticity. Again, it forms 2 bonds. Denticity is 2, right? 3 times 2 is 6. The coordination number is 6. Okay. Okay, I'll write the compound again. This is the compound Fe C2O4 thrice 2 negative. We are just being asked the coordination number of iron. What will be the oxidation state? So this is -2. Oxalate has a charge of -2. So we'll take X plus 3 oxalate are there, and each oxalate has a charge of -2. -2 equals to whole charge, the charge on the whole compound complex is -2. So X minus 6 equals to -2, and X will be equals to plus 4. The oxidation state. This is the oxidation state. Okay. Okay, and the coordination number is 6, which is option C, which I see all of you bachas are answering correctly. Yes, it is due to bidentate ligand. Yes, oxalate is a bidentate ligand. Correct. Good one. Okay, now take a screenshot again. 1, 2, 3, I think. Done. Less hearing. Okay. Voice is less hearing. You know what? Give me just 1 minute, okay? I'll be back. I'll fix this issue. Hello, hello. Is the voice issue fixed now? Just let me know, huh? Okay, 1 second. Voice no problem, ma'am. I think his internet. Hey, don't do that. You made me run out and bring something, bro. That's not okay. Yes, it's okay. I'm not saying the sound not come. I was joking. Voice no problem, ma'am. I think. Okay. It's okay. Clearly visible, right? No, there was something actually. I don't know. Okay, I have to change and everything. Okay, where is the pen? Now I missed the pen. I think I have misplaced it somewhere. Okay, now let's start with the next question. We are not getting a break yet, okay? Yes. Done. So now answer this one. Match the. Okay, this is a very interesting question from Biomolecules. Why do we use anhydride? What is the purpose of, what structural prediction we found when we used these reagents? When we used these reagents with what? Okay, I have to charge. When we have to use these reagents okay. Damn, Afan, your favorite chapter is Biomolecules. That's very... Yes. Okay. So for the time being, I may not be able to see your comments. So don't get disheartened if I don't see your answer. Okay. I'll try to see actually. Okay. Now see, when we use acidic anhydride, what is the purpose of using acidic anhydride? What is the purpose of using acidic anhydride? So, when we use acidic anhydride, in that case, we get to find one thing, that we get what? We get pentaacetate. In that case, we get pentaacetate. And pentaacetate means that there are 5 hydroxyl groups. 5 hydroxyl groups, 5 OH groups are there. And due to these 5 OH groups, okay, this is giving this reactions with acidic anhydride. So it shows what structural prediction we can find, that glucose have 5 hydroxyl groups. Let's see if I can just answer with this, right? I want to save some time. So it could be either option A, C, B or option D. It could be option B or it could be option D. Now bromine water. In case of bromine water, what happens? There is one carboxylic group formed. So bromine water is a very mild oxidizing agent. It can only oxidize up to aldehydes. It can only oxidize aldehydes, and since we are getting one carboxylic group, one carboxylic acid group is getting formed, that means one aldehyde group is there. Okay, one aldehyde group is there, mild oxidizing agent. Okay, so that means glucose have one aldehyde group. Now let's see if I can differentiate on the basis of this. B1, B2. Oh, I got it. Correct answer is option B, right? I don't even have to check these, but this is easy. When we use hydroiodic acid with glucose, what structural prediction we make, that we get what? We get N-hexane. That means all the carbon atoms in glucose, C6H12O6, all the carbon atoms are present in a straight chain. All the carbon atoms are present in a straight chain. So that means this glucose, okay, so yes, the correct answer is option B. In case of hydroiodic acid, what do we get? Glucose has a straight chain of 6 carbon atoms. Okay, in case of hydrogen cyanide, at one position we have this C, CN, OH, H, CH2, 4, and again CH2OH. So at one we get this hemiacetal kind of thing. Okay, yes, hemiacetal kind of thing. It's not acetyl actually. So we have this kind of compound where one CN group is there. Normally these kind of reactions are your nucleophilic addition reactions, and these happens with carbonyl compounds, either ketone or acetone, either ketone or aldehydes. Okay, so again this means that glucose has a carbonyl group. So all of you are answering D. Yes, ma'am, please tell chemical formula of acetic anhydride. Khushi, this is acetic anhydride. This is acetic anhydride, and if you want a clear diagram, so it kind of look like this: CH3COO, CH3. This is acetic anhydride. I hope it is clear. Okay, again guys, take a screenshot if you want. 1, 2. Okay, done. Next question. The correct sequence of amino acids, hormones, vitamins, carbohydrates. So firstly you should know, I don't know, even I don't know, I'm very weak in biology, but something I know. What? That, okay, let's start with amino acids. Thymine, thyroxine, vitamin A, glucose. Thyroxine is a hormone, but thymine is not an amino acid. Thymine is a vitamin. So that means this is incorrect. Okay. Aspartic acid, it is an amino acid, it is not a vitamin. Aspartic acid is not a vitamin. Okay, it is an amino acid. Okay, so that's obviously it's incorrect. Okay, arginine, it is there, it is an amino acid. Testosterone, we know. Glutamic acid, again glutamic acid is also your amino acid, not vitamin. Glutamic acid is amino acid. Okay, so again this is incorrect. So obviously this is your correct answer. Again, you hit and trial. Thank you so much. So again, yes, you hit and trial, you know something, you don't know something, as in I knew that aspartic acid and glutamic acid are amino acids, so that means B and C are not the correct answer. Here I would have some confusion, but I do know that ascorbic acid is normally a vitamin, right? Vitamin C, you get it, ascorbic acid, right? So yes, that means correct answer is option D. Next question. Which examples of carbohydrates exhibit alpha linkages? Hormone, yes, that is hormone, that is correct. We are not talking about this, right? This is hormone, that is correct. This is arginine is a amino acid, that is correct. But glutamic acid, this is not a vitamin. Glutamic acid is not a vitamin, it is an amino acid. If you have read the essential or all those amino acids. Okay, I'll give you one trick also. So we have essential amino acids, that's PV, TIM, A-Hyl. Okay, so phenylalanine, okay, valine, tryptophan, tyrosine, isoleucine, HI becomes histidine, isoleucine, M is your methionine, A is your arginine. Arginine is there, right? Let me just check once. Arginine. Yes, arginine, isoleucine, arginine, histidine, leucine, lysine. Arginine. HI. This HI means histidine. Lysine and leucine. Lysine and leucine. Clear? So these are the 10 essential amino acids. 3, 4, 5, 6, 7, 8, 9 and 10. Sorry for the bad handwriting, but these are the 10 essential amino acids. 10 essential amino acids. That's a trick to learn it. PVT, Tim, a Hill. PVT, Tim, a Hill. Essential amino acids. Okay, again take a screenshot please. 1, 2. Next question. Which of the following carbohydrate exhibit alpha linkages? Now alpha linkages. Okay, where do we have alpha linkages? So do we have them in glucose, fructose? No, we don't, because glucose is a single monomer unit. Fructose is a monomer unit, right? They do not have any kind of linkages. So obviously this is not the correct answer. Now let's look here. Maltose, lactose, both have beta linkages. Okay. Cellulose, glycogen and amylose, amylopectin. Again, amylose and amylopectin have alpha linkages. So we have amylose. They are important actually. Sometimes questions might get asked from this. Amylopectin. Both are component of starch. Okay. Now what speciality do amylose have? Amylose are water insoluble. They are water insoluble. Okay, amylose and amylose are water soluble. Okay, amylose are water soluble. Okay, sorry, Ma'am's bio is also weak, but I'm trying. Water insoluble. This constitute around 15 to 20%, and this around 80 to 85% of starch. Okay, 80 to 85%, 15 to 20%. This has alpha 1,4 glycosidic linkages, and this have two alpha 1,4 and alpha 1,6 glycosidic linkages. Okay, so the correct answer is option B, which, oh my god, somebody is spamming. Why? Where the conversation stopped? No one. No, where you? Okay, what is going on here? Okay, yes, the correct answer is option B. Okay. Again, cellulose, lactose also, this also have beta 1,4 linkages. Okay. So the correct answer is option B. Again, take a screenshot. Okay. Next question. In the titration of potassium permanganate against ferrous ammonium sulfate, we use sulfuric acid instead of nitric acid. Why is that? Because we need to maintain the acidic medium. Why? Because as I told you, whenever MnO4 negative, this is MnO4, right? Potassium permanganate. Whenever MnO4 negative is given, it will reduce itself to Mn2 positive. And for this reduction, what do we need? In this case, we need Fe2 positive. This is Fe2 positive, ferrous ammonium sulfate. That means Fe2 positive is there. Okay, so for this reduction, we need Fe2 positive, and to maintain the Fe2 positive, we need to maintain the acidic medium. Okay, okay. Now, we don't use nitric acid, we only use sulfuric acid. What is the reason? Because we know one thing, that nitric acid is a very strong oxidizing agent. So instead of letting this reaction happen, Fe2 positive will get converted into Fe3 positive. What will happen? This nitric acid, it will react with Fe2 positive. Nitric acid will itself react with Fe2 positive and convert it into Fe3 positive. Nitric acid will itself react with Fe2 positive and convert it into Fe3 positive. So now we don't have Fe2 positive. How will this reaction happen? It won't happen, right? So we use a dilute sulfuric acid, okay? Again, we can't use HCl also, because again HCl will react with this one, right, and interfere with the reaction, okay? So we only use dilute sulfuric acid. Why not nitric acid? Because nitric acid is an oxidizing agent, okay? It's an acid, but it is also an oxidizing agent. So it oxidizes Fe2 positive to Fe3 positive and thus interfere with the reaction. This is incorrect. Obviously nitric acid is as strong as sulfuric acid, okay? So all of you are answering D. Now you are answering C. I don't know what's going on. 1 second. What is going on? Don't spam, everyone, please don't spam. Okay, 1 second. Yes, done. Spam, don't spam guys, don't spam, please don't spam. Aspartic acid not there in your trick. Aspartic acid is not there. Arginine I added 10, only 10 are there, right? I'll check and get back to you. Please don't spam, please study. We are here to study, we are here to, we have here for the rank booster series. Are you ready? You guys have the Josh actually. Today I felt the Josh with you guys. Okay, so again, take a screenshot, right? Why do we don't use nitric acid? Because nitric acid itself is an oxidizing agent, and now as it is an oxidizing agent, it oxidizes the iron to iron 3 positive, right? And the reaction will not happen. The reaction, this potassium permanganate with ferrous ammonium sulfate. Okay, done. Let's move on to the next question. I hope you have taken the screenshot. Next question, the group reagent. This is your group analysis, okay? So this is majorly you have done in your practicals, PU boards, practicals, right? So even if you have not done it, it's okay. 1-2 questions will come, okay? So the group reagent NH4Cl and aqueous ammonia will precipitate which of the following ion? So they are a group reagent for which particular group? So you have group 1, 2, 3 up to 5 cations you have, group 5 cations you have, right? So every cation, every group cation deals with a different group reagent, right? Different group reagent you use to precipitate them out. What is this actually? This is your qualitative analysis, right? Qualitative analysis means that you are given a mixture of compounds, given a mixture of salts actually, okay? In that you have cations, in that you have anions. You need to tell what is this mixture made up of, which anions are there, which cations are there, okay? So for this analysis, for cation analysis, you have group 1, 2 up to 5, right? And each group needs a different reagent to, like, we know that this group reagent, group 2 will show reaction with this only, group 3 will show reaction with this reagent only. So if they are there, if group 2 reagents, group 2 cations are there, they will react and we will see that, oh, this reaction happened, that means group 2 cations are there. Oh, this reagent we used, this is only susceptible to group 3 cations. If this reaction happened, then obviously you will see the change. Okay, let's not go too much deep into this. The basic ones we require here. So your NH4Cl and NH3 and NH3 aqueous is used for which one? Group 3 cations, okay? So we have NH4Cl and NH3 aqueous, okay? This is used for group 3 cations. Group 3 means group 1, group 2, these are higher actually, okay? Group 3, group 1 and group 3. So for precipitating Al3 positive. For precipitating Al3 positive, okay? Your comments are so far I can't see. Okay. 1 second. Okay. Harshit, what is your question? I haven't studied anything for CT and don't know anything. I am at level 0. What to do? Harshit, start with okay. You have done your PU boards, right? You have given some exams. So if you have given your PU boards, if you have some conceptual knowledge for your PU2 syllabus, so start with your PU2 syllabus. Every day, do one thing. Every day, one shot. Some chapters are lengthy, some chapters are short. The lengthy chapter, one shot. Watch the one shot. We have our what do you call it? I forgot the name. We also have one series where we do this all one shots. We'll complete the lecture in one shot. Watch that one shot. After that, make short notes, little bit, not that deep notes, short notes, questions. Solve PYQs. Solve PYQs, okay? And one chapter will be done like this. Done. One chapter done. Similarly, do at least finish your PU2 chapters. There are 10 chapters there, okay? These 10 chapters if you do, trust me, you are going to score 40 something in chemistry only, okay? Similarly, for all these subjects, you'll have to do that. Not only for chemistry, you need physics also, maths also, okay? So from today onwards, if you're start if it, let's say if it is your day 0, okay, it's okay. You can start now also. It's 11th, right? We have 10 days almost, right? From 20 till 21 we can do. So every day do this, and at the end of the day revise. At the end of the day revise. Okay. So watch one shot, make short notes, then again solve PYQs, and then at the end of the day revise. That chapter is done. Now next day start new chapter, do whole the same thing, but at the end of the day revise the first chapter and the second chapter. Similarly, third day, first, second and third chapter revision. Okay. If you're starting from 0, that is, okay. Master stroke series, yes, we have the master stroke series. Thank you so much. I forgot the name actually. Yes, the one shots will cover the complete KCET syllabus, and it's actually much more beneficial. It will only tell you the part that you need to know for your KCET. It won't go into too much details. It'll go into details, but only the details that you need to know for your KCET exam, okay? Because PU syllabus is little vaster than your KCET, okay? You have to write subjective questions also, that's why. If we will do as you said, we will get 40 marks. Yes, Prajwal, but I believe, Prajwal, you have been taking our classes, you already have the basic. For you can expect more than 40 marks if you are solving questions, if you are doing revision, solving questions, doing mock test, revision, solving questions, doing mock test, and then again analyzing your mock test and mistake notebooks and everything. If you are doing these 4 or 5 things, trust me, no one can stop you, okay? And plus your scores should be good, you should be improving in your mock test and all that is also there, okay? Okay, I'll take all of your doubts. Just give me some time. 15 questions let's do. Okay, then we'll go. Okay. So again, this reagent is used. Please be patient. Okay, once we are there in 30 questions, I'll answer your doubts. Don't worry. Okay. Please, huh? Yeah. First and second are not there. It's okay. Whatever was there, only from that portion question will come. 1-2 questions are there. Next question I think also. Okay, so the correct answer is aluminum. These are used to precipitate which group cations? Group 3 cations, and group 3 cations means aluminum. Okay, now take a screenshot. Next question. In the precipitation of sodium fusion extract, normally we use sodium fusion extract for qualitatively analyzing our anions, right? For anions. So why do we use it? First of all, the purpose is to convert the elements. Before even you start the analysis, you make a soda extract, right? Sodium, metal, you heat it up, you mix it and all, right? That whole process. We used to do it, and our fusion tubes used to burst on our faces and all, right? So yeah, you should be very careful while dealing with that stuff. So the main purpose was to convert whatever organic compound you are given, that has covalent bonds, right? So the purpose was to convert that covalent compound into an ionic compound. That purpose was to convert that covalent form into ionic form. That was the purpose, so that the analysis becomes easy. Right? Yes, so the analysis becomes easy. Correct answer is option B, right? So we convert this from their covalent form to ionic form to make analysis easy. Clear? Okay, done? Yes. I will give you time, don't worry. I will give you time to ask your questions. They are not silly if you are asking genuinely doubts and all. Okay, next question. Okay, next question. The sodium fusion extract again is boiled with concentrated nitric acid while testing for halogens. By doing so, what do we do? So when we make that sodium fusion extract, right? We boil it with concentrated nitric acid. What is the purpose of that? Because while boiling with concentrated nitric acid, if there is any sodium sulfide or sodium cyanide present, we decompose that while heating with concentrated nitric acid. If sodium sulfide or sodium cyanide is present, to eliminate them we heat it with concentrated nitric acid. Okay, that is the only reason. Oh, are you hating? Don't do that. Don't spam, please. Children are answering the question here. Let them be. Don't spam here, please. Okay. Yes. So the correct answer is option D. The main purpose is to decompose, because these interfere with the anion analysis. Okay, these will interfere with the anion analysis. So by doing so, we are doing what? We are decomposing Na2S and NaCN. Okay, while extracting with sodium fusion extract, if we are heating it with concentrated nitric acid, it will eliminate both of these. Okay, next question. Which of the following is not an aromatic compound? Now in this one, I'll clear your diagram a little bit. This is plus. This is 3, 4, 5, 6 minus 3, 4, 5, 6. This is also minus. Okay. Now you tell me which of the following is not an aromatic compound. So firstly, you should have a criteria. What is aromatic? What is non-aromatic, right? So we have aromatic and anti-aromatic. These two are really important. So just listen. An aromatic compound is cyclic. An aromatic compound is cyclic. It is planar. It is conjugated. And it has 4n plus 2 pi electrons. 4n plus 2 pi electrons. Okay. 4n plus 2 pi electrons. This is called Huckel's rule. This is called Huckel's rule. Okay, so whenever you are given an aromatic compound, it will follow all these conditions. It will be cyclic, it will be planar, it will be conjugated, and it will have 4n plus 2 pi electrons. So 4n plus 2 means if n is equals to 1, so that means how many electrons? 6 electrons. If n is equals to 0, that means 2 electrons, right? So these all comes into the aromaticity criteria, right? These all compound, any compound who is following all of them, not either, all of them must be followed, then it is called an aromatic compound. Now for anti-aromatic, everything is same. Should be cyclic, should be planar, should be conjugated. One thing is different. It has 4n pi electrons. It has 4n pi electrons. Instead of 4n plus 2, it has 4n pi electrons. Okay. Now we have aromatic done, anti-aromatic done. One is left, which is non-aromatic. Non-aromatic. Non-aromatic means they are not aromatic at all. That means they are cyclic. Maybe they are cyclic. Yes. They are non-planar or non-conjugated. Okay, so they are non-aromatic. Okay, now we are dealing here what? Let's see. Start from here. 1, 2, 3, 4. How many electrons? 4 electrons. So 4 electrons means n equals to 1. 4n pi rule, right? 4n pi is following. So is it aromatic? No, it is anti-aromatic. So this is your correct answer. Now check here also. Cyclic, conjugated, cyclic, conjugated. 1 second. Cyclic, conjugated. Sorry, I missed your comments. Yes. Okay, done. So again, cyclic, planar, conjugated, everything is there. Cyclic, planar, conjugated, but it has 4 pi electrons. 4 pi electrons. 1, 2, 3, 4. Plus. This is plus. Okay. Now look here. 1, 2, 3, 4, 5, 6. One lone pair is also there. 7, 8. That means we have how many? 1, 2, 3, 4, 5, 6, 7, 8. 8. No, I did something wrong. Oh, it is also plus. It is also plus. It is also plus. 1, 2, 3, 4, 5, 6. Yes, 6 pi electrons. 6 pi electrons. 6 pi electrons means again following the Huckel rule. Okay, it is cyclic, it is planar, it is conjugated, and it is following the 4n plus 2 pi electron rule. So that means it is aromatic. It is aromatic. Again, cyclic, planar, conjugated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 electrons. Again, 4n plus 2. When n is equals to 3. 12 plus 2, 14 electrons, right? So again, aromatic, 1, 2, 3, 4, 5, 6. 6 pi electrons, conjugated, cyclic, planar, right? So only this one is your anti-aromatic, which means it is not an aromatic compound. Not an aromatic compound. Ayo, Vishwanath, you came back. Don't do that. Please don't do that. Don't do that, Vishwanath. You are not letting others study. You are a bad person. Yo. Don't do that, Vishwanath. Please don't do that. Okay. Net is slow, huh? Done. Ma'am, you're counting 2 pi electrons for one double bond. Why it is one, right? Ayo, why are you doing that? Whenever you have a pi bond, see, whenever you have a pi bond, a bond is formed by sharing 2 electrons, right? So any bond, pi bond means any bond will have 2 electrons. So we have one pi bond here, one pi bond, that means there are 2 electrons. Similarly, this pi bond also 2 electrons. Clear? So any bond you have, bacha, every bond has 2 electrons. Every bond is formed by sharing of 2 electrons. Okay? So pi bond also have 2 electrons, right? Sigma bond also have 2 electrons, right? Resonance and Huckel related. So resonance means conjugation. Resonance means conjugation, and resonance happens in 3-4 cases. I'll tell you. So resonance happens if you have a double bond, single bond, double bond, or if you have a double bond, single bond, lone pair of electrons, or if you have a double bond, single bond, triple bond also, or if you have a double bond, single bond, and an empty orbital. This is an empty orbital. In all of these cases, bacha, you will have resonance, or you can say conjugation. Okay, so conjugation and resonance are a little different. Resonance happens actually. Resonance normally we talk about in rings. When we're dealing with aromatic system or cyclic rings we talk about resonance. But conjugation we can use in straight chains also. Straight chain compounds we have, there we can also use it. Okay, so that is the only difference, and they are related as in if a system is has resonance and it has 4n plus 2 pi electrons, then it is aromatic. If it has resonance but it has only 4n pi electrons, then in that case it is anti-aromatic. Okay, remember it. Okay, so conjugation is there. The fancy word is resonance. It's used for specific cases, but conjugation is there. Clear? Yes. Okay. Yeah. Okay, ma'am, yes, these are PYQs. Noha, these are your PYQs. Last year PYQ for KCET chemistry. 60 questions we are solving today. Okay. Wow, Sharon, I did not know. That was not in that is not a skill I have. Okay, just take a screenshot of this. Okay, 1, 2, done. Okay, next question. The IUPAC nomenclature. Now, I think you can see it. We have a double bond and we have a triple bond. We have a double bond and we have a triple bond. Which is given more priority? Tell me which is given more priority in between double bond and triple bond. So, I'll tell you the priority order also. You can write it somewhere. So, firstly, I'll give you the priority order. Then you answer till then which is given more priority, alkene or alkynes. Okay, so the priority order, in case while you're writing an IUPAC name, while you're writing any compound's name, okay, organic compound name, the IUPAC name, and if you're given multiple functional group, in case of multiple functional group, a sequence is maintained. Okay, so let's say if I have 2 functional group, one is given more priority, that means this is your primary functional group, and this secondary functional group which is given less priority, this will become a substituent, this will become a parent, this will become a substituent, and this will become a part of the parent chain. Okay, understood, I hope. Okay, so priority order I'll give you, just remember it. Okay, yes, 20C is the correct answer. Let me check. Okay, so the correct order is carboxylic acid is given the most priority. After that you have sulfonic acids, you can say. Yes, sulfonic acids. Okay, then after that you have ester, acid, chlorides, acid halides you can also say. Okay, okay, amides. Then amides you have cyanides. Cyanides are CNL just. Okay, then you have again aldehydes, ketones. Aldehydes are given more priority than ketones. Then after ketones you have alcohols, amines. Alcohols, amines. Alcohol, amines, and then you have alkenes and alkynes. So alkynes is given less priority than alkenes. And what do you mean by less priority? That means while I am numbering my chain, while I am numbering my compound, I will start numbering from my primary group, primary functional group. I want to give the primary functional group the least number. I want to give the primary functional group according to this priority the least number. Then I'll give the secondary functional group as the greater number. It doesn't matter to me. Now let's see. Now let's see here. Okay, C is the only option which is correct. Yes, Sharan, correct. Triple bond is no, Joe. Alkenes and alkynes, alkenes is given more priority. Double bond is given more priority. Now see here. So that means this bond is given more priority. We'll start numbering from here. 1, 2, 3, 4, 5, 6. Right? So here the double bond is at first and third position, double bond, and the triple bond is at fifth position. Triple bond is at fifth position. So this is my correct nomenclature. Why? Because alkenes are given more priority than alkynes. If alkene is given more priority than alkynes, that means what? That means you are having what? The numbering will be starting from alkenes, not from alkynes. So we are numbering from alkenes. Okay. So it will be 1 hexa. How many carbons are there? Hexa. Then again 1 3 diene and 5 YNE. Clear? Because these are given more priority. I don't understand Kannada, Harshit. Okay. Yes, so the correct answer is option C. Okay, write it down, the priority order and everything. Take a screenshot. Okay, yes. Next question. Among the following which is not an isomer of hexane? Very easy. Isomer of hexane. Hexane isomer means having same molecular formula but different structural arrangement maybe. Okay, so let's see how many 1, 2, 3, 4, 5, 6 carbons. This is hexane's isomer. Tell me the answer. For this one, tell me the answer. Very easy. Very easy. Okay, yes. So yes, all of you answered correctly. Correct answer is C. Because this is not an isomer of hexane. Structural arrangement is different, but here we are talking about a cyclic form. It's not a hexane anymore. It became cyclobutane, right? It's cyclobutane. So that's a whole different compound we went to, right? So that is not an isomer. So the correct answer is option C. Not an isomer. That is option C. Okay. Ma'am, we write second exam, it shows the repeater in the mark sheet or not, and best or of 2 there or not. Harshit, I don't have an idea about that. This will be much perfect if JJ ma'am answered it, because she has much more knowledge in this aspect than me. Okay, but I don't have any idea. Sorry, I can't answer you at the moment. Okay, either you talk to her or I'll let you know if anything I came up with. Okay, I get to know about. Okay. Next question. The organic compound can be classified as, how do you classify it? We have this carbon here, and this carbon is forming a bond with chlorine, right? So it's a halide. What kind of halide it is? Allylic halide, benzylic halide, arylic halide, alkyl halide. What kind of halide is it? Very easy, right? C, allylic halide. Allylic means there is a double bond. There is a double bond and there is a carbon or there is a compound attached to this double bond, and to this compound, to this carbon, to this element, the halide is attached. That is your allylic halide. Okay, that is your allylic halide. Okay, now let's see. This is obviously not allylic halide. Benzylic halide means you have a benzene ring. To this benzene ring a carbon is there, and to this carbon a halide group is attached. Oh, this looks similar, right? This looks similar. Benzylic halide. So that means the correct answer is benzylic halide. Again, aryl halide. Aryl halide is this when the halide group is directly connected to the benzene ring. When the halide group is directly connected to the benzene ring, that is your aryl halide. Alkyl halide, when you have an alkyl group directly connected to the alkyl group directly connected to the halide. Alkyl group directly connected to the halide, that is your alkyl halide. So yes, the correct answer is B. Yes, good. Next question. Chlorobenzene reacts with bromine gas in presence of anhydrous AlBr3 to yield. You need to name the reaction. So what reaction we are talking about? We have chlorobenzene. If you treat chlorobenzene with Br2 in presence of FeBr3, in presence of AlBr3 actually, okay, in presence of AlBr3, you get the product, this one. You need to tell me the name of this reaction. Very easy, I know, but sometimes you guys get confused, so I'll clear it up a bit. So whenever, whatever be the type of reagent, whatever be the type of attacking species, whatever be the type of attacking species, that is the name of the reaction. So if an electrophile is attacking, it will be electrophilic substitution. If a nucleophile is attacking, it will be nucleophilic substitution. Okay, so in this case, what species is attacking, that is very important. So here, what species is attacking? We have Br. Okay, what Br, ma'am? What do we do with this? Okay, so AlBr3 reacts with Br2 and we get Br positive plus AlBr4 negative. This is the attacking species. This is the attacking species. This Br positive is the attacking species. Now tell me, how many of you can tell me, is it an electrophile or nucleophile? Br positive, is it an electrophile or a nucleophile? Okay. Yes. Okay, so yes, is it an electrophile or nucleophile? Lion King, correct. It is an electrophile. So if an electrophile is attacking, what it will be? It will be electrophilic substitution reaction. It will be electrophilic substitution reaction. So that means the correct answer is option C. Right? Remember, whatever be the attacking species, the name of the reaction is given on the basis of that also only. Okay, so if the attacking species is electrophile, it is electrophilic substitution. If the attacking species is nucleophile, nucleophilic substitution reaction. Okay, so in this case, this is electrophilic substitution reaction. Why? Because an electrophile is attacking. Br positive is the electrophile. Okay, yes, clear? Okay, now next question. Some of you actually came. Yesterday's live I told you, right? Some of you actually came. That's very nice actually. Okay, now tell me the answer for this one, bachas. Okay, yes, electrophilic, correct, Sharon. Okay, we are almost near 30 questions, because it's going to be a long life. The organometallic compound on reaction with the D2O produces what? So we have this organometallic compound. Firstly, tell me the name of this organometallic compound. What is the name of this organometallic compound? What is the name of this organometallic compound? Looks familiar, right? RMgX. Oh ma'am, that is a Grignard reagent. That is a Grignard reagent, and I think all of you are answering yes. Ma'am, if reagent AlBr3 not given for this reaction, so in that case the reaction will not happen straight away. Then the reaction will not happen. We need the presence of AlBr3, because only in presence of AlBr3 we are able to get Br positive, or else we will not get it. The reaction will not happen in that case. Okay. Okay. Now answer this one for me. So this is a Grignard reagent. Am I correct? Yes, this is a Grignard reagent. Now one more thing, two thing I know about Grignard reagent that you should also know, that Grignard reagent is really reactive, highly reactive. It is highly reactive. That is one. Okay, what is the second thing? So it is highly reactive. Second thing, it is a very strong base. It is a very strong base. Okay, but what about bases? What is so special about bases? So bases have one ability, you can say, one nature of bases, that is they abstract protons. Bases abstract protons. They abstract protons. What do you mean by abstract protons? So abstract protons means they attack protons. What do you mean by attack protons? They give electrons to protons. Okay, bases give electrons to protons. Okay, I hope it is little bit clear. So we have two species. We have bases, we have nucleophiles. Bases are those compounds or those compounds which donate electrons to protons, okay, or which abstract proton, right? What are they doing? They are donating electron to proton. That means they are forming a bond with the proton, right? So they are abstracting a proton. That means they are breaking that bond and forming new bond with proton, right? Like a way of saying things, है ना? Okay, next one. Now you have nucleophile. A nucleophile is electron rich. Electrophile is electron deficient. What does a nucleophile do? It donates electron. Nucleophile donates electron to an electrophile, to an electron deficient species. That is a nucleophile. Okay, so nucleophile donate electron to electron deficient species. Bases donate electrons to a proton. Can you understand the difference now? Bases donate electrons to protons. Nucleophiles donate electrons to an electron deficient species. Okay, electron deficient species. Okay, base have its priority set that it is going to donate electron to proton only. Okay, and your nucleophile, they want to donate electron to any electron deficient, right? Any person comes, I'll give the food. Okay, so you solve this question with me first. Okay, it is abstracting proton. Okay, now let's see here. This will have negative charge, right? And this will have positive charge because it's a metal, it's a non-metal, obviously. Okay, if it is treated with DOD. Okay, now what is this DOD? DOD is just deuterium oxide. Okay, deuterium oxide, yeah. So very easy. You just replaced hydrogen with its another isotope, that is deuterium. Okay, it's still a proton only. It's still a proton only. Okay, with higher mass. Okay, now see. This will have oxygen and deuterium, which will have positive, which will have negative. This will have positive, this will have negative. Again, this negative, this is a base, right? This negative will abstract this proton or donate its electron to this proton. And this oxygen will attack on this one, right? Positive, negative, negative, positive. Simple. Okay. Now, what will happen? This bond is getting formed between C and D, right? And all the rest of the bonds are same. Plus Mg OD Br. Is it clear? Everyone, is it clear why are we getting this product? Some of you have asked me before that, ma'am, why not this? Why not this? Well, because bro, it's strong base. It's a strong base. It will abstract a proton. Because it's a strong base, it will abstract a proton. Rather than reacting with this OD, it will rather abstract a proton, rather react with this D. It will donate its electron to this deuterium and form a bond with it, okay? Because it's a strong base. I hope after this lecture you won't have any doubt about nucleophile and bases behavior. They are very different concept. Nucleophile is different, base is different, okay? Nucleophile gives substitution reaction, bases give elimination reaction, right? Nucleophile gives substitution reaction, bases give elimination reaction, okay, because they are that strong. Yeah, the Lion King thermodynamics is not that important. 1-2 question you'll see, okay, so don't worry if you are skipping it, it's okay. Focus on other chapters. It's a little tougher to understand and 1-2 questions comes, not more than that, okay. Next question, shall we? Okay, so the correct answer is which one? This one. Yes, option D. Now take a screenshot, okay? Done. 1-2 seconds, done. Next question. The major product formed when 1-bromo-3-chlorocyclobutane reacts with metallic sodium. So it's a very interesting reaction. You can kind of guess the product. This is the compound. 1-bromo-3-chlorocyclobutane. If it reacts with sodium metal in dry ether. If it reacts with sodium metal in dry ether, what happens? What is the reaction happening? What do you think will happen? It's kind of a it's a Wurtz reaction, right? It looks like a Wurtz reaction. Okay, so what happens here? It's kind of a Wurtz reaction. Okay, what do you call it? The name. I'll tell you the name. You tell me the product. Okay, the name is intramolecular Wurtz. Intramolecular. I think you will have an idea after reading the name also. Intramolecular Wurtz. Okay, whenever we do Wurtz reaction, we get an alkane, right? Normally we get an alkane, RR. A bond is formed between two alkyl groups. Okay, we get an alkane. Okay, but here, what will we get? We have two, right? What will happen here? So these two will get lost and a bond formed between these two carbon. Okay, so I'll draw the product. Intramolecular Wurtz reaction. The product will look like this. Intramolecular Wurtz. Okay, plus 2 NaBr or Cl, whatever it is. Okay. 1-bromo-3-chlorocyclobutane reacts, and what will be the product? So the product is C. Yes, all of you are answering C. Thippet. Rudra is answered C. Done. C. Clear? What is the name of the reaction? Intramolecular Wurtz. So yes, in this case we will get alkyl group. Why? Because there is a bond forming between RR, right? But here, since both the halides are in the same compound only, so again the bond will be formed within the molecule, within the compound. Okay. Yes, you name the product. You name the product. I'll check if it's correct or not. Okay, you name the product. What's your name? Okay, Solo, tell me the name of the product. Okay, you tell me the name and I'll check if it's correct or not. Okay, just take a screenshot. I think 1-2 seconds. Done. Next question. Okay. Yep, it's a bicyclo. Okay, guys. Okay. Ethyl alcohol is heated with concentrated sulfuric acid. The major product is, oh my god, it's so easy, right? Ethyl alcohol. This is ethyl alcohol. And if it is treated with concentrated sulfuric acid, and I'll tell you one thing, if it is treated with any concentrated acid, sulfuric acid, nitric acid, hydrochloric acid, any concentrated acid, okay, and we heat it, 413, obviously we are heating it, okay, and if we heat it, okay, in that case what will happen? Nothing will happen. We'll get an alkene. Okay, water molecule, this is a dehydrating agent. One water molecule is lost, so the water molecule will be lost like this, one H here and CH2 OH here. This is the water molecule that is lost, right? And again these carbons have to satisfy their valencies, so they will form a double bond. So we will have this CH2 double bond CH2, that is an ethene. Very easy, right? Simple. Yeah, see, the correct answer is C, ethene, right? So whenever any alcohol, I'm not talking about just ethanol, any alcohol, if it is treated with a concentrated acid and you heat it, okay, what happens? You get an alkene. Okay, clear? That is a simple reaction. So if you have a propanol, you will get propene. If you have a butanol, you will get butene. Okay, similarly, whatever alcohol you have, that particular alkene you will get. This reaction is called dehydration of alcohols. You know, it's very funny because you guys might have studied it in your 10th standard. It's in a 10th standard. Yeah, it's literally in 10th standard. Okay, temperature is 413. Yes, you see, that is also very high temperature, right? High temperature, 413, 273, 373, 100 degrees Celsius is 373, right? So obviously it's greater than that. You're heating it. That means you're heating it. That's an idea you can give. You can tell also the ethanol has a really less boiling point. Okay? Yeah, that is 10th standard, huh? Okay. Next question. Phenol can be distinguished by propanol. So phenol is an aromatic alcohol. Propanol is an alkyl alcohol. Phenol is an aryl alcohol. So tell me, how do you differentiate between those? This is phenol and this is propanol. How do you distinguish between these two? How do you distinguish? So for you, I don't know, but I know myself that whenever I treat this phenol with bromine water, it is so reactive. It is so reactive with this bromine water that it will form 2,4,6-tribromophenol. It will form 2,4,6-tribromophenol. This is actually white. This is actually a white colored compound, white product. Okay, so whenever you treat a phenol with bromine water, it reacts so extensively that it forms 2,4,6-tribromophenol. Okay, and this is white color, so we can distinguish. And what happens when you treat bromine water? You know, propanol with bromine water? No reaction. No reaction happens. Okay, no reaction happens. Ma'am, 26 question, I think A. Please, which question are you talking? Oh, no, that won't happen. No. I'll check once, okay? 26 question, I'll check once. But that was, no, that was no. The answer key I matched actually. The answer was that only, okay? Answer key I also matched, no? Oh, Nalin, hi, it's okay. That depends on different temperatures also. Okay, so yes, for this one, the only test that we can use to differentiate between phenol and propanol, that is your bromine water, because in this case we get a white PPT, a white product, this white product 2,4,6-tribromophenol, and in this case no reaction. Iron metal, no, you don't use iron metal directly. We use iron chloride. Iron chloride we use, and then we get a violet colored product with phenol. Okay, iodine in alcohol, that is not also used, and sodium metal, again it gives reaction with both propanol and phenol. Sodium metal will give reaction with propanol as well as phenol. Okay, 1 second. Yes, the correct answer is A. What are you guys fighting about? I don't understand. 413, 443, 420, 143. What is going on? Okay, yes, so we all agree the answer is A. Okay, just take it. 1, 2, done. Next question. Match the following with their correct pK values. Okay, now very interesting one. pK values. How is pK value related to acidity and how is pKb value related to basicity? Okay, so very easy. You have a thing called Ka value and Kb value. So Ka and Kb tells us about the acidity and basicity. Acidity of acids and basicity of bases. Okay, so they are directly proportional to the acidity and basicity. This is directly proportional to acidity. This is directly proportional to acidity, okay, and this is directly proportional to basicity. This is directly proportional to basicity. So higher the Ka value, highly acidic that solution, that compound is. Higher the Kb value, highly basic that compound is. Highly basic that compound is. Now how is pKb related or pKa related? Inversely. They are inversely related. Okay, so if the pK value is really high, that means the acidity is really low, right? If the pK value is really high, that means the acidity is really low, right? Similarly, if the pKb value is really high, that means the basicity is low. But if the pKb value is small, that means the basicity is really high. Okay, I hope you are getting what I'm telling you. Okay. Yes, pK directly for base, inversely for, don't confuse it much. Just simply remember this, that Ka is directly proportional to acidity, and acidity, both of these things, Ka as well as acidity, are inversely related to pK. Why? Because we know pK is what? Nothing, negative logarithm of Ka. Negative logarithm of Ka. So it is going negative, right? In opposite direction. Okay, now you have to tell me, we are given 4 compounds, which among the following is most acidic? Which among the following is most acidic? I think you know picric acid, right? Picric acid, this is picric acid. When you have 3 nitro groups. Okay, some few other concepts are also there. I'll try to sum them also. Now listen. Whenever an electron withdrawing group is attached, to the ring or anywhere, an electron withdrawing group, that means it will withdraw electron from where? From here also, from this OH bond also, right? That means it will withdraw electrons from this OH bond also, right? because these NO2 groups are electron withdrawing, and whenever an electron withdrawing group is attached, it will withdraw the electrons from the OH bond also. So if the OH bond electron is getting withdrawn, the what happens? The bond is weak, right? The bond is really weak. So even if little pump is there, okay, this H positive is really loosely held, okay, so this get lost very easily whenever any compound comes, or you know, whenever you want to react it with something which is a base or something, this will immediately, any base, what does? Base extract a proton, abstract a proton, right? So if any base comes, this proton is very easily loosely held. Why? Because obviously oxygen has taken all the electrons from this hydrogen. It has no electrons left. So if any base comes, it immediately lost this. It immediately lose this proton, right? And this is the factor we talk about acidity. Acids give H positive, right? Acids give H positive very easily, okay? So if H positive is lost easily, it is highly acidic. It is highly acidic. That means highest Ka value and least pK value. Least pK value, which has the least pK value. This, right? So that means picric acid will have a pK value of 0.78. Okay, now we have 3 other options to go through, but let's see if we can just answer on the basis of this. No, we can't. We have option A and option B. Okay, now let's check. For para-nitrophenol and phenol, when it is para-nitrophenol and phenol only, this is para-nitrophenol and this is phenol. Now listen. Very easy, na? See, when we are already given here, NO2 is an electron withdrawing group. If it is an electron withdrawing group, it will withdraw the electron. Again, withdraw the electron from OH bond. The H is weakly held. Any base can abstract this proton very easily, right? It is still more acidic than this one because there is no electron withdrawing group attached to it. Okay, so that means the in the decreasing order, if you are going, the second acidic will be para-nitrophenol. So that means after 0.78 we see 7.1. So for B, the answer is 4. For B, the answer is 4. Again, that's a tie. That's a tie. We can't distinguish on this basis also. But we know after para-nitrophenol, phenol will be there. Phenol will be there. Okay. So phenol will have around 10. So that means A is 3. A is 3. So your correct answer is option A. Your correct answer is option A. Okay, 1 second. Think I've lost you guys. Okay. Okay, I think my net is not working. Okay. Wow, only if you study from this angel, then though I have some, you know, I am of benefit to you all. But if you're not studying, if you're just focusing on other things, that's not nice, no? Okay, clear? So everyone agrees it's a B. Why you B? B. It's A, no? See, if I'll just write them in the increasing order of pK values. I'll write them in the increasing order of pK value. Most acidic. Increasing means firstly we'll start with the most acidic, then we'll go to the least acidic. Most acidic is picric acid, then after that para-nitrophenol, then after that phenol, then after that ethyl alcohol. It doesn't have anything, ethyl alcohol. So that is around 0.78, that is around 7.1, that is around 10, and that is around 16. So which is the correct answer? D. I am answering it correctly. A3. Phenol is 10. Phenol is 10, which means A is 3. A is 3. Option A. Why are you all answering? Madhukar, the answer in the answer key answer I am telling you, that was the answer. Okay, I know you might be getting confused, maybe there was some misprint or something, but we are getting ethene in there. Or I'll 1 second, I'll check in the break. Okay, don't worry, I'll check in. We are just done. Let's do the 30 questions first. Okay, then I'll check and tell you. Okay. Yes, the correct answer is A. Next question. Again, this reaction. It's a very easy one. Why? Because I know when this compound is there, and I treat it with HI. So here this is delta positive, this is negative. Again here two possibilities are there. In front of my eyes I see two possibilities. Either bond break from here or the bond break from here. From where the bond will break? Now tell me from where the bond will break. The bond will break when the compound, when the intermediate or the compound that you are getting is stable, right? If I break the bond here, okay, if I break the bond here, what am I getting? This one, carbocation, right? This carbocation is tertiary carbocation, and tertiary carbocation are exceptionally stable. Tertiary carbocations are exceptionally stable. But if I break the bond from here, that means I will be getting this one, CH3 positive. That is a methyl cation. That is a methyl carbocation. That is highly unstable. Highly unstable. So obviously, the product or the bond breaking will be favored from that side where we are getting a stabler intermediate, that is from here. So the bond will break from here, okay. So what will happen here? It will get delta positive, this will get delta negative, right? Carbon will have positive charge, oxygen will have negative charge. Here we know positive, negative, right? So this negative will attack this positive and this negative will attack this positive. So what will happen here? There will be a bond between carbon and iodine. Okay, rest are the same. Plus CH3OH. CH3OH. Is it clear, everyone? Is it clear? Is it clear? So which is the product we get? A and B. So we will get where the bond is formed between CI, this one and this one. C. The correct answer is option C. Okay, yes, Madhukar, correct. The correct answer is option C. Why? Because we tried two possibilities. We had possibility 1 and we had possibility 2. We tried breaking both the bonds. When we broke the first bond, what happened? We got a tertiary carbocation. Now that carbocation is very stable. Obviously, it will favor the formation of that carbocation. But if we break on the second possibility, according to second possibility, we are getting a methyl carbocation that is highly unstable, highly unstable. So obviously the bond will break from the first site, this one, okay, and then here we get H positive and I negative is there. So this negative will attack this positive and this negative will attack this positive. So we will get an alcohol plus this alkyl halide. We will get an alcohol plus this alkyl halide, okay. Clear? So the correct answer is option C, hai na? Okay, just take a screenshot, okay, and then we'll move on to the next question, okay. Okay, next question. Yes, tertiary is stable, correct. Oxidation of toluene, it's a name reaction. It's a name reaction. What is the name of this reaction? So I'll write the reaction, till then you gave me the name. It is very easy, right? So whenever you have an toluene, oxidation of toluene, okay, with chromial chloride followed by hydrolysis, chromial chloride followed by hydrolysis will give us benzaldehyde, What is the name of this reaction? The name of this reaction is Etard reaction. The name of this reaction is Etard reaction, okay. Again, Cannizzaro, it happens between two aldehydes or ketones that do not have an alpha hydrogens. Stephan reaction is for your nitrile compounds. Nitrile compounds undergo Stephan reaction. Okay, and Kolbe reaction is also for formation of carboxylic acid we use. For the formation of carboxylic acid. Why B, Shankar? No. Some of you are also answering C. Wait a second, your comments got missing, I think. Yeah. Etard reaction, yes. And okay, sorry. Yes, it is the one of the preparation of benzaldehyde. Yes, correct. So all of you are answering Raju, Jo, Vimla, Deepa, Darshan, Solo, Sai. Okay, 1 second. Okay, so the correct answer is option A, Etard reaction. The name of this reaction is Etard reaction. Okay. What is Etard reaction? It is the preparation of formation of benzaldehyde when you do oxidation of toluene. So oxidation of toluene with chromial chloride followed by hydrolysis gives us benzaldehyde. That is what? That is Etard reaction. It is used for the synthesis of benzaldehydes. I am famished, okay? I am famished actually. I want some water, okay? Please take a screenshot of this, and then we'll do the next question. 1, 2, 3, 4, done. I'll explain it once. Give me 1 minute. Sai, what is your question? Please tell me your questions, I'll answer, okay? Now listen. So when you have this compound, okay, this compound, O, there is two possibilities. There are two possibilities of breaking bonds, okay? We can either break this bond or we can either break this bond. Let's say I name this possibility 1 and name this possibility 2. So when you break the bond via first possibility, what happens then? I break this bond, this will get the negative charge obviously, and this will get the positive charge. This is a carbocation, right? What kind of carbocation it is? It is a tertiary carbocation. Just look at here. This is a tertiary carbocation. This is a tertiary carbocation. Okay, that is my one possibility. I get CH3O negative and this carbocation, which is tertiary carbocation. Okay. Second possibility, if I break this bond, okay, in that case what I will get? This alkoxide ion, O negative, alkoxide ion, and this is CH3 positive. This CH3 positive, which is a methyl carbocation. And I know methyl carbocation is highly unstable. Methyl carbocation is highly unstable in compared to tertiary carbocation. So which will form? The formation of the tertiary carbocation is favored. So that means you will get a tertiary carbocation, right? We have CH3O negative and a tertiary carbocation. Then we have H positive and I negative. Again, in H positive and I negative, again positive negative is there, right? So this negative will attack on the positive, this negative will attack on this positive, we will get CH3OH, and there is a bond between C and I. Okay, so that means the correct answer is option C, not B. Why? Now you know, because of the stability of tertiary carbocation over this methyl carbocation. What is going on, guys? 1 second. Where there is no ester ether here. This is alcohol, this is alkyl halide. Yeah, where is? There's a difference. Ester is this, where 2 oxygens are there. Ether is this. Only one oxygen, RCOR, you can say. Only one oxygen is there. That is ether. You're still stuck on 26th question. Macha, give me some time. 1 minute give me. You are still stuck on that. I'll just check once, okay? Just give me some time. I'll check. Till then, you guys take a screenshot of this one actually. No, we have not answered the. Yes, this one. Okay. Hello everyone, hello. Okay, so done. I think we are back. Now, to answer your doubts, okay, yes, I checked it. Okay, I think I made a mistake this time. Okay, we have two temperatures. Okay, I'll correct my mistake. Okay, I'm really sorry and thank you for pointing out for all the other kids. Okay, thank you for being persistent, actually, that you were persistent. Because of that I look into it and there was an error from my side. Okay, I'm sorry. Okay, so what is that question? This one. Okay, in this question, when ethyl, we have to remember the temperatures. We are given two temperatures here. When one is 413 Kelvin and the other is 443 Kelvin. Okay, one is 413 Kelvin and the other is 443 Kelvin. Okay, so when 413 Kelvin is there, what happens? At this temperature, intermolecular dehydration happens. Intermolecular dehydration. Again, dehydration means loss of water molecule, but within two molecules, within two different molecules. And when we have 443 Kelvin, in that case, intramolecular dehydration happens. That within the same molecules, a water molecule is getting lost within the same molecule. Okay, so what happens here in this case? Intramolecular dehydration. Okay, so the temperature is 413. So what will happen here in this case? Intermolecular dehydration. That means you do two molecules and we remove a water molecule from those two molecules. How? Okay, I'll just correct it. Okay, so if we have CH3, CH2, OH, one molecule. Similarly, second molecule of ethyl alcohol will be there, right? Intermolecular dehydration, that means a water molecule is getting lost from within, like from two molecules, from two different molecules. So let's say OH from here and H from here. This is getting lost as water. OH from here and H from here. This is getting lost as water. What are the condition? Acid, concentrated H2SO4, any acid at 413 Kelvin. 413 Kelvin. Okay, only in that case. Okay, sorry. Okay, 1 second. Now listen, I'll answer your doubts, but just listen here once. Listen, see, when we treat it with concentrated sulfuric acid at 413 Kelvin, okay, what happens? Intermolecular dehydration, that is two molecules are there, and from both of these two molecules, one water molecule is getting lost, okay, that is the water molecule that got lost, minus H2O, and what will we get? CH3, I'm just writing it here, CH2O, CH2, CH3, that is diethyl ether. Diethyl ether. Okay, that is one case. If the temperature is 443 Kelvin, in that case, intramolecular dehydration happens, and in that case, we get what? An alkene. So here, at this temperature, you will get an ether, and at this temperature, you will get an alkene. So remember it, and thank you for pointing out my mistake. Okay, I'm really sorry. I misread it or somehow I misinterpreted it. Okay, it's okay. Okay, yes. Please correct it. Once again, I am sliding back. You can take a screenshot. Intermolecular dehydration. That is what happens here. Diethyl ether. Okay, now let me check your doubts. Okay, I am giving you 2-3 minutes for your doubts. Okay, Meghna, if you are studying from zero, yes, you can still score good marks in your KCET, right? But bacha, you have to be consistent. You have to be disciplined. You have to be consistent. You have to start working on your concepts, okay? And then solve questions and revision. Concepts, questions, and revision, okay? Okay, now what else is, who else is there? Mahiboob, what's your name? Mahi. So Mahi, if you start now also, you can do it, okay? But you'll have to be consistent. No more social media, no more friends, no more going out. If we have really less time, 10, 11 days, you have to lock in, you have to sit down, you have to start. At least if maybe, you know, if you actually have good knowledge, if you have good conceptual understanding, right, you can just revise it and you solve questions, you can get good marks, okay? Hi Meghna. Okay, what you want me to tell you once again? Ma'am, I got 100 in maths, 95 in physics, 83 in chemistry. Oh my god, do you want to, if you are getting 278 out of 300, don't waste your time rewriting, okay? You already have a really nice percentage, so use that and focus on your KCET. If you are preparing for KCET, focus on your KCET, okay? That is much more important. Okay, I'll tell you once again. How many I need to score? 81 is a nice score. Anyway, if you're going above 80, that is a very nice score, okay? Focus on your KCETs for now, okay? I'll just repeat the question. So this question, ethyl alcohol is treated with concentrated sulfuric acid at 413 Kelvin. So remember, two temperatures are there whenever we are dealing with acids and alcohols. At 413 Kelvin and 443 Kelvin. When the temperature is 413 Kelvin, intermolecular dehydration happens. That means two molecules are there, and from those two molecules, one water molecule is lost, okay? At 443 Kelvin, intramolecular dehydration happens. That means within the same molecule, one water molecule is getting lost, okay? So here the temperature is 413 Kelvin, and in presence of an acid, what will happen? Intermolecular dehydration. That means from two molecules, one water molecule is getting lost, right? So these are the two molecules. What are the two molecules? Ethyl alcohol, right? Ethyl alcohol. From both ethyl alcohol, one water molecule is getting lost, and there is a bond forming between these two alcohols, right? If one water molecule is lost, we will get ether. We will get ether, that is diethyl ether, okay? So the correct answer is option A, okay? I hope you have took the screenshot, okay? Please, now one more thing, please don't spam the chats. I'm looking for the answers here. And if you got anything about 80 in your chemistry, and you know your total aggregate is above 85%, please don't spam here. It's okay. The marks thing has gone. PU board has gone. You know, you have gotten your marks and everything. Focus on your KCET. Focus on your future for now. Okay. Please don't spam here. Okay. You have doubts, as I've told you, obviously see whatever options suits you best, okay? If you think you can improve in that, then obviously write your improvement exam. But if you already have close to 90% marks in your aggregate, if you have 90%, obviously why are you wasting time writing that, right? Focus on other exams. You have other exams that you can give, okay? Yes. I can't understand. Yes, obviously, MET exam. I don't know, have an idea. MET is, which exam is MET? This will help for KCET, that I'm sure. MET, I have no idea. I'm sorry. Yeah. Let's solve the questions. Okay. Question number 31st. Reduction of ester by dibyl H followed by hydrolysis gives aldehyde. Okay. Oxidation of benzyl alcohol with aqueous KMnO4 leads to the formation of benzaldehyde. So one I know, the other I don't. I know when I treat ester with dibyl H and followed by hydrolysis, I also hydrolyze, okay? What happens? I get an aldehyde. Yes, that is correct. That is one of the method of preparation of aldehydes. That is correct. But if I treat benzyl alcohol with aqueous KMnO4, it is a very strong oxidizing agent. Will the reaction stop at aldehyde? Nope. The reaction will go up to carboxylic acid. This is not the product we are getting. We will be getting carboxylic acid in that case. Yes. Okay. Bye, Tasmia. Okay. we get benzoic acid. Yes, we will get benzoic acid. We will not get benzaldehyde. We will get benzoic acid. That means your statement 1 is correct, but your statement 2 is false. Statement 1 is correct, but statement 2 is false. The correct answer is option B. The correct answer is option B. 1, 2, 3. Next question. Okay. Okay, arrange the following in decreasing order of reactivity towards nucleophilic addition. Now, as I told you, the reactions are named on the basis of attacking species. If the attacking species is nucleophile, we call it nucleophilic substitution, nucleophilic addition and all, right? Now we are talking about nucleophilic addition, so that means a nucleophile is coming. Now nucleophile will attack what? An electrophile, right? So that means we should have a good electrophile here, right? Only then the reaction will happen, right? And the good the electrophile, the fastest the reaction will happen, right? The good the electrophile, the fastest the reaction will happen, okay? Okay, now which among the following is the best electrophile? Okay, let's check once. Okay, we have aldehyde. These are your ether, right? These are your ethers, and these are your ketones. This is ketone and this is aldehyde. So I think when you studied about aldehyde ketones, your teacher would have told you that, bachas, aldehyde and ketone, two species are there. Which is more electrophilic? Aldehydes. Why? Because in aldehyde we have one hydrogen. This is aldehyde, right? Because in aldehyde we have this one hydrogen, and due to this hydrogen, this group is plus I. It is donating electrons, increasing the electron density. Why? Because in between carbon oxygen is more electronegative. It is withdrawing all the electron density from the carbon. It is withdrawing all the electron density from the carbon, right? That means this is electrophilic. This is electrophilic. This R group is supplying electrons to this carbon. So electrophilicity is decreasing. But only one R group is there, right? How much electron will it supply? Now look at ketone. Look at ketone. Same thing is happening for ketone, bechara. It is poor papa, papa ketone. Okay, same thing is happening for ketone. What is happening? Again, the oxygen is withdrawing the electrons from carbon, right? But here the case is different. In ketone, we have two R groups. Okay, now these two R groups will provide the electron density to the carbon. So obviously here, only one is the provider. Here, two is the provider. Two are the providers, right? So obviously it is much more stable and less electrophilic. It is less electrophilic. Now, if I have a nucleophile, okay, you can also think it in a way that C is a person, right? His mom... okay, C is the person, right? This person's mom is earning and dad is at home, let's say. Okay, here both mom and dad are earning. Okay, and if any, let's say this is Mr. Beast comes and wants to give money to this child. Okay, so this will accept it, the help. Why? Because obviously both of their parents are not working and they have some monetary problems. But here both the parents are working. It's already satisfied enough. It will take, but obviously not with the same intensity with which this one take. Okay, so again nucleophile will attack much faster here than this one. I'm really sorry for the bad example if it was. Okay, but to give you an idea of how electrophilic and nucleophilic works. So which is more electrophilic here? Aldehydes are more electrophilic. Why? Because only one alkyl group is there to increase the electron, to provide the electron density. Here two alkyl groups are there that will provide the electron density, and in this case this is less electrophilic, this is more electrophilic. Nucleophile easily attack this than this one. Okay, so here we have one aldehyde and two ketones. So obviously which is the most reactive among these? The aldehyde. The aldehyde which will be the most the aldehyde which will be the most reactive. Okay, so aldehyde, okay, which has the aldehyde, either option A or option D. Now in between these two, let's see, in between these two also some factors are there. Two factors are there exactly. So first one is your plus I effect and second one is your steric factor. Okay, now in between we have CH3CO CH3 and we have CH3CO C2H5. Both have plus I. Okay, that is not an issue. Okay, both are less electrophilic than aldehyde. That is also not an issue. But among these, this is a bigger group. That means the steric hindrance factor is there. This is so big that whenever a nucleophile comes, will it be able to attack let's say this is the nucleophile. It doesn't have any position to attack. It can only attack from this side. It can only attack from this side, obviously. So the rate will decrease. The reaction, the reactivity towards nucleophile will decrease because only one possibility is there for this, right? So the order will be this one, the least. It will be the least reactive towards nucleophilic addition reaction. Okay, it will be the least reactive towards nucleophilic addition reaction. Mahantesh, please stop spamming first of all, and second of all, there is no chance the same question will repeat. Obviously, if it came in 2025, use your brain, it won't be repeating in 2026. Okay, concepts, yes, they will repeat. This concept, some different compound they will give, and they will ask the rate towards nucleophilic addition reaction. Okay, so concept will be same, but obviously you won't get same question, bacha. Use some brain, what is going on with you? Okay, most probably if any question will get repeated, that will be from your 2024, 2023, 2022, but don't wait on for the exact question to get repeated. Okay, they will use the same concept knowledge, same type of questions. Okay, that means the data is different, the compound will be different, but the knowledge will be same, the concepts used will be same. Okay, you should keep that in mind. Okay, don't go like, ma'am, I studied PYQs, I am full ready. No, if you don't know the concept, then you are not ready at all. Okay. Okay. Sangeeta, very easy. Nucleophilic addition and substitution. Addition means new bond will form. Okay, a new bond will form. Okay, here what happens? Actually, what happens here, we normally, this O gets converted into OH and one new bond is formed. Okay, that is your addition. Substitution means any nucleophile will come and will just substitute this. It will come and let's say it substituted this, in place of this R, the nucleophile attached itself. That is substitution. Basic difference. Addition means new bond is getting formed, some new compound or atom is getting added. Substitution means some other new atom came and substituted the atom. Bonds are still the same. All bonds are still the same. Very basic, very basic. Okay. Machine, stop spamming. I am literally calling you out. You're doing that. Okay, guys. So just, okay, I'll just, 1 second. Just take a screenshot of this. Okay. I hope you will have an idea. The correct answer is option A. Okay. Just take a screenshot, please. Yes. How much are you scoring now, Sadhana? Yes. Okay. Next question. Which of the following is the most acidic hydrogen? Most acidic hydrogen. I told you, most acidic hydrogen will be the one which is lost so fast. You know, as soon as any base come, the proton is gone. As soon as any base come, proton is gone. That means the weakest bond possible. Okay. All are acids. So that means they have this kind of thing. The weakest this bond, easily this proton is lost. Okay, highly acidic, the most acidic that compound is. Okay, I hope it got in your brain, right? So I can tell you without even like looking at the answer, trichloroacetic acid, 3 chlorine group. What are these chlorine groups? These are halogens. These withdraw electron density. They have minus I effect. They will withdraw the electron density. If they withdraw the electron density, they will withdraw the electron density from this bond. They will withdraw the electron density from this bond. They will also withdraw the electron density from this bond. Okay. Now, if they are withdrawing the electron density from this bond, this proton, if any base come, it can abstract this proton very easily. Why? Because the bond is really weak, really weak. Okay, so the correct answer is trichloro. More the number of such groups, more the number of electron withdrawing groups, highly more acidic that compound is. Simple. More acidic that compound is. More acidic the compound is. Okay, I hope it is clear. Yes, after question 60 is done, I'll give you all a break. I will also take a break for myself also. Okay. Yes, done, I think. Yes, okay. So please take a screenshot. Yes, more the number of electron withdrawing group, more acidic that compound is. Okay. Next question. Which one of the following reagents are suitable to differentiate between aniline? What is aniline? This is aniline. This is aniline. It is a primary amine. It is a primary amine. Okay. N-methyl aniline. N-methyl aniline means N-methyl aniline. It is a secondary amine. So which of the following test you can use to differentiate between a primary amine and a secondary amine? Primary amine and a secondary amine. Very easy, very easy. How? Because we know primary amines give a test that is called carbylamine test. That is called carbylamine test. And I see the reagent for that. Chloroform and alcoholic potassium hydroxide. Chloroform and alcoholic potassium hydroxide. This is a reagent for carbylamine test. What is carbylamine test? Whenever a primary amine is treated with chloroform and alcoholic potassium hydroxide, it is treated with chloroform and alcoholic potassium hydroxide, we get isocyanide. We get a compound called isocyanate. Okay, isocyanate. So in this case, we will get this. Please don't go on my writing, okay? I try to write nicely, right? And this is a foul smelling compound. It's very foul smelling, pungent, okay? It's pungent. You can smell it from a distance and you're like, oh, it's a primary amine, okay? So it's foul smelling. Don't want to smell it. Some smells are really bad for your nose, okay? They ruin your nose forever, okay? Yes, we will do, yes, definitely we will do something for COMEDK. For now, we are focusing on KCET, but yes, alongside you should watch these lectures because they will be as beneficial for your COMEDK as well. And obviously, we will be doing for COMEDK after this, okay? Yes, the correct answer is IUPAC. This one, carbylamine test, simple. The test that can distinguish between primary and secondary amine, because aniline is a primary amine and N-methyl aniline is a secondary amine. Why? Because in this case, 2 carbon, nitrogen is bonded to 2 carbons. Here, nitrogen is bonded to only 1 carbon. Okay, so this is a primary amine. This is a secondary amine. How do you distinguish? Using carbylamine test. Carbylamine test. Okay, so the correct answer is option D, which now all of you are answering option D. Yes? Okay. Okay. Next question. Which of the, oh, one second. Okay, just take a screenshot. I'm sorry, I missed it. I will remember it from the next question onwards. Okay, isocyanate actually. But you don't have to worry also. One of you was worrying about the notes also. So we have a WhatsApp channel. The link is in the description of this video. Okay, it is live actually. Okay, you can just go to that WhatsApp channel. This PDF gets uploaded there. Okay, I make this PDF and I upload it there only. Okay, so you can just go and check it out. Okay, the WhatsApp channel link is in the description of this live. So you can just go and right how to open that. Okay, here. I think we have it. Yes, here the Join Diksha KCET WhatsApp channel. You can just click on this and there you'll be able to, yes, there you'll be able to join the WhatsApp channel. There the PDF gets updated. Okay, okay, yes. Now let's move on to the next question. Which of the following reaction does not yield an amine? Does not yield an amine. That's so simple, right? Yes, it is. Why? Because we know this is a monolysis of alkyl halide. This definitely will yield amine because this is one of the method of preparation of amines. This is reduction of nitriles. Reduction of nitriles with hydrogen, nickel in presence of sodium, amalgam and alcohol. Okay, this is also one of the method for synthesis of amines. So that means this is also correct. Okay, so 1 and 2. Now see. That means 2 is correct, 1 is correct. 2 is correct, 2 is correct. So that means this is not the options. This is not the correct answer. Okay, we're looking for a method which does not yield amine. Okay, 2 yield amine. So that means these options are out. They are out. Okay, now the rest of the 2 options. Okay, amide. When you do reduction of amides, we get amines. When you do reduction of amides, we get amines. Okay, so in that case, again 4 is also correct, but we don't have any option regarding that. 1 is correct, 1 is correct. That means this option is also out. Only third. Actually, this is partial hydrolysis of nitriles. This is partial hydrolysis of nitriles. So firstly, when we do partial hydrolysis of nitriles, we will get amides. and after getting amides, if you do further hydrolysis, which is full or complete hydrolysis of amides, complete hydrolysis of nitriles, complete hydrolysis of nitriles will give you carboxylic acid. Complete hydrolysis of nitriles give carboxylic acid. Partial hydrolysis of nitriles will give amides. Okay, amides, complete reduction of amides will give amines. Reduction of amides will give amines. So only one method is there. Yes, correct answer is C. Good. And all of you are answering C. Good. I'm proud of you all. Okay. Okay, do I have to? Yes. Take a screenshot. Again, you can wait for the PDF in the WhatsApp channel. It will be updated. Okay. Now you have to match the names. Benzene sulfonyl chloride. What is that? Benzene sulfonyl chloride is this is benzene sulfonyl chloride. There is one other name for it. What is that name? That name is Hinsberg reagent. Hinsberg reagent. Why? Because this reagent is used to distinguish between primary, secondary and tertiary amines. Okay. So primary and secondary amines, why this looks sad? Primary and secondary amines give this test with benzene sulfonyl chloride. Okay. That's a Hinsberg test. Okay. Because these primary and secondary amines have acidic hydrogens. Primary and secondary amines have acidic hydrogens. So they give acidic hydrogens. So they give Hinsberg test, which is your reaction with benzene sulfonyl chloride. But tertiary amines does not have any acidic hydrogen, so it does not give this reaction. No reaction. Okay. That is your Hinsberg test to distinguish between primary, secondary and tertiary amines. Okay, that is one. So this is what? Hinsberg reagent. A2, 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 A2. Oh, I find my answer on first try also. Only, D. Now see, sulfanic acid, okay, I don't know about sulfanic acid yet, but I know my alkyl diazonium salts. What is alkyl diazonium salts? This is alkyl diazonium salts. Rn2 positive, Cl negative. Rn2 positive, Cl negative. That is your alkyl diazonium salt. They are highly unstable. I know that, right? They are highly unstable. So they decompose. They decompose into what? As soon as they are formed, they decompose into alcohol. They decompose into alcohol. So I know this also, conversion to alcohols. Aryl diazonium salts, right? This is aryl diazonium salt. Aryl diazonium salts are majorly used for what? They are majorly used for forming dyes. We get azo compounds, right? Have you seen the reaction with aniline? Yeah, aryl diazonium salt. Its reaction with aniline. It forms this yellow color dye. Depending on the condition, yellow or orange. Okay, that depends on the acidic or basic condition. This is the product we get. Okay, this N double bond N. Para-azo-aminobenzene. Para-azo-aminobenzene is yellow colored. Okay, right? So aryl diazonium salts are used to prepare dyes. So obviously sulfanic acid is a zwitter ion. Okay, so in these kind of questions you don't have to put too much brain. If you know 1-2 options, you can just cross check and use it. Okay, yes, phenol orange, correct. NEAX creations, I didn't prepare the paper, bacha. I don't know which will have the highest weightage. So normally we use the analysis of the last 5-10 years papers. So according to that I can tell you, but not that which portion will be higher weightage or lesser weightage. Okay, like that. Okay, let's move on to our next question. Shall we? You guys take a screenshot first. Okay. Then I'll tell you the next question. The number of orbitals associated with N shell of an atom. Structure of an atom. Finally, one question. So you have to tell me the number of orbitals that are associated with N shell of an atom. So when you have N shell of an atom, how many orbitals are associated with N shell? N square, right? Number of orbitals associated, if you have N shells, how many orbitals will be there? N square, right? Okay. So, which among the following you think is associated with N shell of an atom? The question is simple. If N shell is there, so that means the number of orbital associated will be sorry. sorry. Yes, 16. Correct. So the number of orbitals associated should be n square. Okay, which among the following is a square? 4 is a square though. No, 1 second. What are we dealing with here? 1 second, 1 second. Think I yes, the number of orbitals, yes, 16 n square. I think there is something with the answers. 1 second, I'll check. Number of orbitals associated with n shell of an atom. Yeah, the answer should be square. Yes. Just checking, just a minute. Yeah, I know 2 square 4, bro. I know that. Okay. The answer is 16 in this case actually. One second, we are not reading the question correctly. 1 second. Yeah, I'm answering. Sorry. Okay, we forgot it. I also did the same mistake. So we have K shell, L shell, M shell, N shell, right? 1, 2, 3, 4, right? And number of orbitals associated and the number of orbitals associated with n shell. N shell means this K, L, M, N. N means n's value is 4. N means n's value is 4, right? Clear? K, L, M, N. N is 4, right? 1, 2, 3, 4, right? So what will be the value of what will be the number of orbitals? Number of orbitals is equals to n square. N is your principal quantum number, which is 4 in this case. So how many orbitals? 4 square. Orbitals will be 4 square. That is 16. That is 16. So your correct answer is option A. Okay? N is your principal quantum number. Okay? Done? 4 square. Yes, we misread the question. That n was this KLMN shell. Okay? Yes, 16. Absolutely. Good. Everyone is on the same page. They already answered 16, but they didn't know how. Okay. Next question. According to Heisenberg uncertainty principle, you need to tell me the value of delta V dot delta X. Okay. For an object having a mass of 10 raised to the power -6, Planck constant is also given. Now, I know according to Heisenberg uncertainty principle, the uncertainty in position as well as the uncertainty in momentum, their product should be equal to or greater than h by 4 pi. This is Heisenberg uncertainty principle, not me, Heisenberg. Okay? That the uncertainty in position and momentum for an electron or any elementary particle should be greater than or equal to h by 4 pi. Okay? Okay. Now I know momentum is what? M delta V, right? mv. Momentum is mass into velocity. So delta x m delta v, that is greater than equal to h by 4 pi. Clear? H by 4 pi. Okay. Now can I take this m on the right hand side? Yes, I can. So delta x dot delta v is greater than equal to h by 4 pi m. If I calculate this h by 4 pi m, will I get this value? Delta x dot delta v, delta x dot delta v. So you just have to calculate it with me. Delta x dot delta v greater than equal to 6.6 times 10 raised to the power -34 by 4 times 3.14 times m, which is 10 raised to the power -6 kilogram. Your answer will be 5.2 times 10 raised to power minus 29. Minus 29. Without even solving, you get an idea. Minus 34, minus 6 is there. Okay? Minus 34 plus 6. Yes, the answer will be closer to this one. Is it clear? Is it clear to you all? Ma'am, please repeat. Okay, Aryan, right? Ayman, sorry. According to Heisenberg uncertainty principle, we know the uncertainty in position and momentum. If we product them, the product should be greater than or equal to h by 4 pi. Okay, we are asked this delta V times delta x. Delta V is velocity. Okay, so we put the value of momentum. Momentum is m times delta V, right? If I take this m on the right hand side, which is h by 4 pi m, right? This is the product that I was being asked, delta V times delta x. Okay, h is Planck constant, 4 pi 3.14. M mass is also given 10 raised to power minus 6 kilogram. I substituted the values, I calculated it. The answer came out to be 5.2 times 10 raised to power minus 29 meter minus 2 second inverse. Okay. Okay, clear? Yes. Wow, I'm not a biology teacher, Ramesh. Okay, done. Next question. I hope you have taken a screenshot. Yes. Next question. Two statements are given. Adiabatic work done. Okay, I'll tell you one interesting thing. What is adiabatic process? An adiabatic process happens when there is no exchange of heat between the system and the surrounding. There is no exchange of heat between the system and the surrounding. So that means Q is 0. Q is 0. And according to first law of thermodynamics, which I think all of us knows, that according to first law of thermodynamics, the change in internal energy is equals to heat plus work. Either you can bring the change using heat, or you can bring the change using work, or you can do both and still the internal energy will change. Is that clear? Done. Okay. If Q is 0 for an adiabatic work done, Q is 0, so that means delta U will be equals to W. Okay. One more thing is given, that work is done on the system. We have two conditions. We have physics and chemistry, but in chemistry we have two conditions. Work is done on the system or work is done by the system. I am the system. If work is done on to me, if I am given lots of money, then obviously it's positive. Okay. If I am giving someone else money, that means I am transferring someone else's bank account and everything. I am losing that. Work is done by me. Okay. That means that is negative. Okay. So work done on the system is always positive. Okay. If work done is positive, positive means work done is positive. What do you mean by positive? Positive macha means that is greater than 0. If work done is positive, that means work done is greater than 0. If work done is greater than 0, this thing is equal to work done. Change in internal energy is equal to work done. Okay, so that means delta U will also be greater than 0. Delta U will always also be greater than 0. That means internal energy of the system also increases. Statement 1 is correct. Done. Okay. Second statement. No work is done during free expansion of an ideal gas. What do you mean by free expansion? That means we are expanding. But firstly, you know expansion, right? When you blow on a balloon or something, it expands, right? So whenever you are expanding something, free expansion means the process is happening in vacuum. Free expansion means there is no other friction, no other resistance out there. That means the work is happening in vacuum. And when we are dealing with vacuum, what is the external pressure? What is the external pressure? 0. The external pressure is 0, right? Because it's vacuum. In vacuum there is no pressure, no atmospheric pressure. All gases are removed. Vacuum. You know vacuum, right? Okay. Can human beings survive in vacuum? No, we cannot. Okay. So when we know work done is equals to what? Minus P external dV. That much we know. Work done is minus P external dV. If P external is 0, then work done will also be 0. That means no work is done during free expansion of a ideal gas. You can think it in a common sense way also. Whenever you are doing expansion means lots of space is needed, right? You are pushing against what? If there is no external pressure, what are you pushing against? Nothing. So that means it will happen on its own. You don't need to do any work. The process will happen on its own. The work done is 0 for that kind of case. Why? Because there is no external pressure, and because no external pressure is there, there is no force, opposing force or anything. Okay? I hope it is clear. Yes. So both are correct. Both are true. Both are true. please take a screenshot if you want. Okay, yes, and all of you are answering D. Yes, the work done is 0 solo vibe, that is correct. Okay, next question. Okay, which one of the following has this relation? Okay, now before moving on to that relation, I'll tell you the exact relation what is there. Change in enthalpy is equals to the change in internal energy plus delta NGRT. R is rate, gas constant, T is temperature. What is delta Ng? Delta Ng is the number of gaseous molecules of product minus number of gaseous molecules of reactant. Okay, so we are focusing only on the gaseous things. Okay, so number of gaseous molecules that are present in the product minus the number of gaseous molecules that are present in the reactant. So only gas we are dealing with. Okay, this is the exact relation. Change in enthalpy is equals to change in internal energy plus delta NGRT. Now if delta H is equals to delta U, that means this thing is not there, this is 0. That means this thing is equals to 0. When will it be 0? Either temperature 0, but no such thing is given here. Okay, delta Ng is 0. Delta Ng, when delta Ng is 0? When the number of gaseous molecule of product equals to the number of gaseous molecule of reactant. If you subtract them, the answer will be 0. And if you put 0 here, delta H will be equal to delta U. Basic. Okay. Okay. Now see, how many gaseous molecules we have in here in the product? 1. How many we have in the reactant? 0. Delta Ng will be equal to, I'll write delta Ng only, it will be equals to 1 minus 0, which is 1. So if it is still 1, obviously there will be something here, 1 RT. Okay, let's see here, 6, okay, minus 15 by 2. So delta Ng will be 6 minus 15 by 2, which I'm not wrong, will be minus 3 by 2. Clear? That is not 0 either. Let's see here, 1 gas, 2 gas, 2 gaseous molecules on the product side, 2 gaseous molecules on the reactant side. Delta Ng will be equals to 2 minus 2. Oh, we are getting somewhere. Oh, 2 minus 2. 2 minus 2, that is 0. Here again, 2 minus 1 and 3. 1 and 3 means 4. That is minus 2. Okay, so delta Ng here is also minus 2. So only one case is correct, that is option C. Only one case is correct, that is option C. Yes. Okay. Okay, bro, correct, bro. Bro answered correctly. Shru answered correctly. Okay, Thipperedu, can I call you Rudra only? Okay, so correct answer is option C. Why? Because this is a relation between enthalpy change, internal energy and delta Ng. Delta Ng should be 0. For this relation to exist, delta Ng should be 0. When delta Ng will be 0? When the number of gaseous molecule of product is equals to the number of gaseous molecule of reactants. Okay, so that is possible only in case number 3, C. Okay. Okay, now please, if you want, you can take a screenshots. I am going on to the next question. Okay, I went a little fast, I think. Okay. Okay, we have 20 questions left only. Okay, I will be back in 2 minutes. You solve this question, 2 minutes, huh? I'll be back. Okay, I'll see you in 2 minutes. You guys also stay hydrated, drink lots of water. Now see, what will be my first thought after seeing this question? Where did I put the pen? Okay, my first thought will be definitely skip it. Last thought will be solve it, right? That will be my last thought, to solve it. First thought will be skip it. It's too long, no? It's too long. But now I'm not in your place. I can think. What I'll think, that I'll look for a mutual option, one option that I can eliminate. I see which B, okay, no, I see A. A is here also, here also, here also. So if I just check on the A thing, and if it is correct or incorrect, I'll have some idea. Okay, I'll start with A. All the enthalpies of fusion are positive. Enthalpy of fusion, what is fusion? Fusion means melting. Melting means what? Fusion means melting. And what do you mean by melting? When solid is getting converted into liquid. And I know whenever solids gets converted into liquid, we supply energy. We supply energy, obviously, right? Solid doesn't melt on its own. You need to provide heat to it, right? So obviously energy is given. Okay, that means it is endothermic or exothermic? Endothermic. And for endothermic processes, the enthalpy change is positive. Ayo, I wasted my time. A is correct. So that means all of these three can be possibilities. No, I didn't waste my time. See, I eliminated this option. Because now A, C and D, any one of them can be correct. Okay, A, C and D can be correct. Okay, now I look for what? E. Let me check E first, because E is there for these two, right? One I have eliminated. I have three options left. Okay, I'll check for E. Okay, for most of the ionic compounds, del H solution is negative. Whenever you have an ionic compound like NaCl, it is an ionic compound. So when you dissociate, solution means when you add that ionic compound into solution, right? In water, let's say I'm making a solution with water. If I add that in water, what happens? These water molecules come in between these ions, right? We have Na positive, Cl negative, and in between H2O will come. These H2O molecules will come. Okay. Do you think what is happening here? Na positive, NaCl is there. Okay, so whenever you are making a solution of it, water molecules are going to come in between the ions. So that means the Na and Cl bond is going to break. If any bond is breaking, as I told you, whenever you are breaking anything in your life, anything you are breaking, you need to give energy. So that means here what we are breaking, we are breaking the NaCl bond. If we are breaking the NaCl bond, we'll need to give energy. That means the process is endothermic. So the delta H, the change in enthalpy, the delta H should be positive. Ayo, it is written negative here. So obviously that is not the correct answer, right? So E, I eliminated E also. I found the correct answer only by answering two statements, first and last one. Whenever you are dealing with these kind of statement based questions, again just approach it like this, the way I approached it. Look for the option that is present in all of them. A is present, A statement is present in all of them. Eliminate A, and using A we eliminated option B. Then after that, see the next one. E is there, right, in both of them. Or you could have started with D also, but I started with E. You could have started with D, whatever your choice. E was incorrect, so that means this also eliminated, this also eliminated. A is my correct answer. Rest you can also check. Magnitude of enthalpy change does not depend on the strength of the intermolecular interactions. 1 second, did I answer incorrectly? Okay, this is the correct statement. Okay, we answered it opposite. Correct statements are okay. Yeah. I'm so sorry. I'm so sorry. Sorry. It's okay. We can do it. Okay. Enthalpies of fusion are positive. Correct statement. Magnitude of enthalpy change does not depend on, but you know how to approach these questions now, right? But read the questions, obviously, that is the first. I didn't read it properly. The magnitude of enthalpy change does not depend on the strength of intermolecular interaction in the substances. Obviously, it depends. If the strength is really strong, you'll need to give too much energy, endothermic. Okay? Obviously, the magnitude of enthalpy will change. The magnitude of enthalpy change will change. So this is incorrect. B is incorrect. When a chemical reaction is reversed, the value of enthalpy change is also reversed. This is correct. Obviously, it reverses. The change in enthalpy is dependent on the path. Is enthalpy a path function? No, it is not. Enthalpy is a state function. Enthalpy is a state function, not a path function. What are path functions? Only 3 are path functions. Just remember it. Path functions are work, heat, and heat capacity. Work, heat, and heat capacity. Only these 3 are your path functions. Rest everything is state function. So obviously this is incorrect. This is incorrect. And we already figured out this is also incorrect. This is also incorrect. So answer is B, D, E. B, D, E. The first we eliminated. That is our correct answer. Oh my god. B, D, E. I'm sorry guys. Yes. Yeah. Okay. Okay. Yeah. I hope it is clear to you all. Is it clear, everyone? The concepts are same. I didn't mess up with the concept. I only messed up with the options, you know. Yes, B. Okay. Next question. Which of the following statements is true about the equilibrium? So we know equilibrium is a state where the rate of forward reaction equals to the rate of backward reaction, right? That is your equilibrium. And the stage at which all the concentration of reactants and products are constant. Concentration of reactant products are constant. That is equilibrium. So equilibrium is only possible in a closed system. 100%, because in equilibrium, for equilibrium to exist, you need both reactant as well as product. If product is not there, if it is an open system, if the product left, who will you set equilibrium with, right? So obviously this is a must condition. All the measurable properties are constant for at equilibrium. Yes, pressure, volume, temperature, all these things measurable, which you can measure. These all properties are constant at equilibrium. A and B is correct. But do we have any options of A and B only? No. So that means C is also correct. Let's read it. Equilibrium constant for the reverse reaction is the inverse. Yes. So if let's say for this reaction the equilibrium constant is K, and if I reverse this reaction like this, C plus D gives A plus B, then the new equilibrium Kn, the new equilibrium constant for this reaction is equals to 1 by K. It is the reverse of the equilibrium constant of the original reaction. It is the reverse of the equilibrium constant of the original reaction. Yes? Done? Yes, the correct answer is option C. Guys, can I ask you something? Really, I don't know if you'll do it or not. I'll really quick, I'm asking you, okay? Okay. No, we already crossed 100, so I don't want to ask you. Nah, I don't want to sound greedy. I thought it was not 100 in my phone, it was not showing 100. Anyways, we got 100 likes. Damn, yeah. Yes. So, solo vibes, we are left with few more questions. We are almost done. Okay, 60 questions we have to do. You take your time. I think we'll be done by 1:15. Okay, before 1:15 we'll be done. Done? Okay, next question. According to Lee-Catlier principle, formation of methane is favored by. There was a scientist who was Mr. Lee-Catlier. He said a principle, he gave a principle. He said that any system that is at equilibrium would want to stay at equilibrium and would resist any change that is applied to it. So it's like Newton's, any body that is at rest would like to remain at rest, and any object that is in motion will like to remain in motion only. Okay. Similar to that, Lee-Catlier said at equilibrium, if a system is at equilibrium, it would want to stay in equilibrium and would resist any change that is applied to it. This is an equilibrium wala system. This is an equilibrium system. Okay, I'm sorry for the Hindi and all in between. Okay, one second. So, Lee-Catlier principle. This is a reaction, okay, this reaction is at equilibrium. We want to favor the formation of CH4, okay, what will we do? Increase the concentration of CO. Now think, if you increase the concentration of CO, what will happen? The equilibrium shifts. There is a change in equilibrium, right? This is at equilibrium, but we increase the concentration of CO. What will happen? There is a shift in equilibrium. Reactant is more. The reaction wants to balance. Reaction wants to be in equilibrium. So what will happen? It will favor the forward reaction. That reactant is more. So obviously we need to produce the product more. If reactant is more, we need to produce the product more. So obviously it will favor the formation of CH4. So that is correct. Okay. A is correct. Okay. Increasing the concentration of H2O. If we increase the concentration of product, what will happen? Again, the equilibrium shifted. How? Because the equilibrium is unbalanced out. It's not in equilibrium. The system is not in equilibrium. So what will happen? If product is more, the system would want that reactant should be also more. So that again it will come in equilibrium. The system wants to stay in equilibrium. The system loves equilibrium. Okay. So what will happen if product is more? What will happen? More reactant will form. If more reactant will form, backward reaction is favored, right? This is not favored. CH4 is not getting formed anymore. Okay. So again, no, this is not a way to synthesize more CH4. Decreasing the concentration of CH4, very easy. Yes. If you decrease the concentration of CH4, in that case, what will happen? Again, equilibrium is disturbed. Now, in this time, the product concentration is less. So what will the equilibrium do? It will increase the product concentration so that the system becomes at equilibrium again. System comes at equilibrium again. So yes, this favors. So do we have an option with A and C? Yes. Again, decreasing the concentration of H2. Again, if you decrease the reactant concentration, the reaction will go in backward direction to increase the concentration of reactant. Okay. The system loves equilibrium. If it is in equilibrium, it would want to stay that way. Okay. Anything that is disturbing it, so sometimes you can manipulate it, to get, we want CH4 more. So what we will do, we will increase the concentration of CO. The system is like, oh, it's not an equilibrium. I need to produce CH4 more so that the system becomes at equilibrium again. System comes at equilibrium again. Okay, second thing, I increase the concentration of H2. In that case also, equilibrium will think that again the reactant product balance is gone. So I want to increase, so I want the equilibrium again. What I'll do, it will increase the concentration of product again. More synthesis of CH4. Okay, again decreasing the concentration also works. Okay, I hope you get an idea now that equilibrium, any system at equilibrium would want to stay at equilibrium and will resist any change that is applied to it. Okay, so the correct statement is A and C. Where is the break? Anusha, break is after 17 questions. The equilibrium constant for this reaction, it's very easy, very easy. Okay, we have this reaction A plus B is in equilibrium with C plus D. Initial concentration is given, which is 1 m each. At equilibrium, we need to find the equilibrium concentration of D. Remember it, we need to find the equilibrium concentration of D, right? And the equilibrium constant is given, Kc is also given. At equilibrium, what happens? Some of the reactant has been converted into product. Some of the reactant has been converted into product. The reaction has gone in forward direction. So let's say X amount of this reactant has reacted. Similarly, X amount of this reactant also has reacted. See, some amount of product would have been formed. Some amount of this product would also have been formed, right? Very easy, right? When reaction is going on, reactant concentration is decreasing, product concentration is increasing, right? Equilibrium constant. Equilibrium constant is equals to the ratio of the product of concentration of products divided by concentration of reactants. Okay, what are the products here? Concentration 1 plus x. Can I do just square? 1 plus x, 1 plus x. 1 minus x, 1 minus x. 1 minus x square. What is Kc? Kc is 100. Kc is 100. This is equal to 100. Can I take a square root? This is equals to 100. If I take a square root, 1 plus x upon 1 minus x equals to 10. If I solve it, okay, guys, be patient, okay? Don't freak out. Very easy. 11x will be equal to 9. X will be equals to 9 by 11. The answer will come out to be 0.818. Now, most of you see this option and click ID. Wrong. Why wrong? Because we are asked the equilibrium concentration of D. What is the equilibrium concentration of D? 1 plus x. The equilibrium concentration is 1 plus x. We found the x, we just need to add 1. So the equilibrium concentration of D will be 1 plus 0.818, which is 1.818. 1.818, and most of you answered B. See, I told you some of you will answer D. See, you answered D also. Hina, why you answered D? Okay, yes, B. Oh my god, A is unique, actually unique. Okay, that is the answer. Very easy, simple, right? We know at equilibrium some product have been reacted and some reactant has been reacted and some product has been formed. Okay, next question. Okay, 1 second, just take a screenshot if you want. 1, 2, 3, 4. Okay, among the following 0.1 m aqueous solutions were given. complete lowest boiling point elevation. So we know elevation in boiling point, which is delta TB, is equals to I kbm. I is your Van 't Hoff factor. Okay, more the number of ions. Okay, equilibrium elevation in boiling point is a colligative property. That means it depends on the number. That means it depends on the amount of solute present. If more amount of solute is present, more elevation in boiling point will happen, right? If less amount of solute is present, less elevation in boiling point will happen. We are asked the lowest elevation in boiling point. Lowest elevation means the least amount of solute. Least amount of solute. Okay, so your least amount of solute means least I value, least I. Let's check the I values here. Aluminum chloride is AlCl3. That means 1 aluminum, 3 Cl. That means I is equals to 4. Okay, potassium sulfate, K2SO4. 2K positive and SO4 2 negative. That means 2 and 1, 3. I is equals to 3. Okay. Aluminum sulfate, Al2. SO4 thrice. 2 aluminum and 3 sulfate, 5. I equals to 5. Okay. Sodium chloride, NaCl, Na positive, Cl negative, I is equals to 2. Now, which will have the least I value, least Van 't Hoff factor, or least Van 't Hoff factor will have the lowest boiling point elevation. Clear? So boiling point elevation, see, we are not asked the highest elevation boiling point, we are asked the lowest elevation boiling point. That will be for the compound that have the lowest or least amount of solute. Which will have the least amount of solute, that will have the least Van 't Hoff factor. This have 4 ions, this have 3 ions, this have 5 ions, this has only 2 ions. So this will show the least boiling point elevation because it has the least amount of solute or least amount of solute molecules or anything you call. Okay, so the correct answer is D, and all of you agrees. Clear? Yes? Okay, good. Okay, done. Okay, next question. Oh, it's so easy. Henry's law. The variation of solubility with the temperature. We are talking about the solubility of gases in liquid. We are talking about solubility of gases in liquid. So when we talk about solubility of gases in liquid, we talk about one thing, macha. What thing? That whenever you try to solubilize any gas in liquid, that process is exothermic. That means heat is getting released here. Heat. Okay. Clear? If you increase the temperature, what will happen? If I increase the temperature, again the system is at equilibrium, solubility is happening, right? Gas is getting solubilized in liquid and heat is getting released, right? But if I increase the temperature, what will happen? This heat will increase, right? Again, heat is more. What will happen? Equilibrium will shift. In which direction? So that this heat get balanced. Here heat is getting absorbed. Here heat is getting released. So it will go in the backward direction where heat is getting absorbed. In forward direction, what is happening? Gas is getting solubilized in liquid and heat is getting released, right? In backward direction, what is happening? Liquid is absorbing this heat and getting converted into gas. Liquid is absorbing this heat and getting converted into gas. Now heat is more because we have increased the temperature. We are increasing the temperature, okay? If you increase the temperature, what happens? Balance. The system is not at equilibrium anymore. What will happen? It will want to stay in equilibrium by releasing that excess heat, and that reaction will go in backward direction. That means the solubility will decrease. We are getting gas only. It's not soluble anymore. So that means the solubility decreases with the temperature. That was the explanation for it, okay? But the relation is like this. Solubility is inversely proportional to temperature and directly proportional to pressure. It is directly proportional to pressure and inversely proportional to temperature. If you increase the temperature, solubility of gases and liquids decreases. If you increase the pressure, the solubility also increases. So the correct answer is option D. Correct, Chantana, Aniket? Done. The correct answer is option D. That is according to Henry's law. Done? 1, 2, done? Next question. You need to tell the temperature at which the solution boils, at which this water boils. So we have pure water, we have pure water, and one water, this is water. In here we added water plus glucose. In here we added water plus glucose. You need to tell me the temperature at which the second one, at which this, not first one, the second one will boil. You need to tell me the temperature. Yes, escape the solution. So in question 45, we are talking about lowest boiling point elevation. Lowest boiling point elevation means that the least amount of solute is there. Least amount of solute. Why? Because elevation in boiling point is a colligative property. That means it depends on the amount of solute or the number of solute. If least amount of solute is there, the elevation in boiling point will be the least. So we calculated when aluminum chloride is there, it dissociates as Al3 positive and 3Cl negative. So that means we have 4 ions here. In case of K2SO4, we have 3 ions. In case of aluminum sulfate, we have 5 ions, and in case of sodium chloride, we only have 2 ions. This is the least amount of solute present. Now, if this is the least amount of solute present, that means what? That means this is the least elevation in boiling point. This is the least elevation in boiling point. Okay? Done? Because these are colligative property directly related to the amount of solute. Yes. That is a different equation. We are not dealing with that. The ion want or factor with association, dissociation. Okay, that is a different topic. Okay. I mean, that the definition. See, want or factor relation with association and dissociation. Their relations are very important. You need to remember it. And this thing you can figure out on your own, right? Aluminum chloride will dissociate as Al3 positive, 3Cl negative. How many ions? 3, 1, 4 are there. K2SO4 will dissociate as 2K positive, SO4 2 negative. How many ions are there? 3 ions are there. Okay. So that is, you can easily figure out. And those formulas that are there, 1 minus 1 by alpha into n, that 1 by n into alpha, that formulas you have to remember for us. Ionization, association as well as dissociation, that are important. Okay. Okay. Next question. This is done. Next question. Again, we need to calculate we need to tell the temperature at which this water boils. This water boils at 373.15. Okay, at what temperature will this water boil? So we are talking about elevation in boiling point. We are talking about elevation in boiling point. What is elevation in boiling point? This is elevation in boiling point. What is this? The boiling point of solution, minus the boiling point of pure solute. Because there is elevation happening, that means the temperature is increasing, the boiling point is increasing. So boiling point of the solution after adding the solute minus the boiling point of pure solvent is equals to Kb times m. M means molarity. Okay. We have this value. Molarity is easy to find out. How? Molarity is what? Number of moles of solute present per kilogram of solvent. Number of moles of solute present per kilogram of solvent. What is the number of moles of solute? 180 gram present in 180 gram of solute. And what is the molecular mass of solute? 180 gram. Glucose molecular mass is 180 gram. Okay. Times what is the amount of solvent? Amount of solvent is water. Water's amount is 1 kilogram, right? So molarity is 1. So that means TBS minus this value is 373.15 equals to KB. KB 0.52 times 1. So that means this will go that side. TBS will be equals to 0.52 plus 373.15. So that is around 373.67. 373.67. Option A. Clear? Yes, correct answer is option A. Easy, right? Because we know all of these data. What is delta TB? This is elevation in boiling point. This is the increased temperature minus the original temperature. That is the elevation. That is the boiling point has increased by that amount. Okay. KBM, M is molarity. Molarity is number of moles of solute present in 1 kilogram of solvent. Okay. That is the relation. Molarity was 1, Kb value is already given. We need to calculate this value only, okay? So you should be clear in your concept. When we talk about depression freezing point, that means in depression of freezing point, what is there? The solvent's melting point, sorry, the solvent's freezing point is higher than the solution's freezing point, okay, because there is a depression happening, lesser than the pure solvent value, okay. Asha, just some time, we are almost done. See bacha, 50 questions are. I am also tired, I know. Kit Kat break I gave you, Sharan, in between, so please take a screenshot and we'll go to the next question. If N2 gas is bubbled, calculation, pure calculation. N2 gas is bubbled through water at 293. How many moles of N2 gas would dissolve in 1 liter of water? Assume that N2 gas exerts a partial pressure of 0.987. Now I know Henry's law. Henry's law said that partial pressure of nitrogen will be directly proportional to the mole fraction of nitrogen, right? And if I remove this proportionality sign, partial pressure of nitrogen will be equal to mole fraction of nitrogen times the Henry law constant for nitrogen, okay? Now I know partial pressure is 0.987 equals to mole fraction of nitrogen times 76.48 kilobar. Remember it, the answer is in kilobar. Kilo means 10 raised to power 3. You will multiply it with 10 raised to power 3. Your mole fraction, what is your mole fraction? 0.987. Trust me, I am also getting tired. Okay, 76.48 times 10 raised to power 3. Okay, the answer will come around 1.29 times 10 raised to power minus 5. Okay, now one more thing. We need to calculate the mole fraction. Sorry, we need to calculate the number of moles of nitrogen. Okay, so number of moles of nitrogen. We have the mole fraction of nitrogen. How do you calculate number of moles? Mole fraction is equals to number of moles of nitrogen upon total number of moles. Now see, here, for 95% of the questions, you don't have to worry here. You can just take the mole fraction of water here. You can only take the mole fraction of the water or solvent, any solvent you are given. You can just take the mole, you can take the number of moles of that solvent only, because the amount is usually this much in this much of a solvent, okay? So we have here around, if you see, the partial pressure is only 0.987. So the very small amount of N2 will be there normally, okay? So you can just assume it. Okay, we have 1 kilogram. 1 kilogram of water. 1 liter of water means 1 kilogram of water, right? So that means how many moles? Number of moles of water are 1000 given mass upon molecular mass, which is 18, 55.55. Mole fraction is 1.29 times 10 raised to power minus 5 multiplied by number of moles of H2O, which is 55.55, and that is equals to number of moles of N2, and number of moles of N2 are 7.16 times 10 raised to power minus 4. Number of moles of N2 are 7.16 times 10 raised to power minus 4. Hello, I am alive. I'm not asking about me, I think. Ma'am, I'm not understand what I see on the board, or you, ma'am. Oh my god, Aniket. See board, bro. Obviously, don't see me. Okay. C. Yes, the correct answer is option C. Good. What's your name? You actually, I think, PG, what's your name? PG Aeon. I'm so sorry. But still, Aniket, this board will be helpful in your exam. I won't be helpful. I won't be there. No, this knowledge will be there. Okay. Yeah. Anyway, so the correct answer is option C. Okay. I hope it is clear. We firstly calculated the mole fraction of nitrogen by this equation. Partial pressure of nitrogen is directly proportional to the mole fraction of nitrogen, right? If we replace it with a KH, which is Henry law constant, the values are given to us. Mole fraction comes out to be 1.29 times 10 raised to power minus 5. Mole fraction is number of moles of nitrogen by number of moles of water. Why? Because amount is very small. Okay, we can just ignore the number of moles of nitrogen in the denominator. Okay, because it will complicate the calculation, nothing else. Okay. Number of moles of water was what? 1000. 1 liter of water, that means 1 kilogram. 1 kilogram is 1000 gram. 1000 by 18, 55.55. If you multiply the mole fraction with 55.55, you will get the number of moles of nitrogen. Number of moles of nitrogen, that is 7.16 times 10 raised to power minus 4. Okay. Okay. Good. Okay. Good. At least you are impressed. Take a screenshot and we'll move on to the next question. Don't down your Josh yet. Okay, how's the Josh, guys? Please pump up. You're almost there. 11 questions to go. How's the Josh, guys? Wow. Okay, yes. How's the Josh? Is it still high? I haven't eaten anything and I'm shouting more than you. Well, obviously you can't shout, but at least be there in the comments. Yes, ma'am, Josh is high. You can finish it. We're almost 10 questions down. Oh my God, Chandana. What happened, Chandana? Deepa, good. Oh my God, Bhavanish, okay, done. Also tell ma'am, I did that. Repeat, what do you want me to repeat, Megha? Tell me after this, like 60th question we are done, tell me the number of questions, Megha. Megha, right? Megha, yes, I will repeat it, don't worry, okay? Yeah, okay, so, how's the Josh, guys? Let's start. The correct statement you need to tell. In galvanic cell, current flows from cathode to anode. I know one thing, in galvanic cell, this is anode, this is cathode. Electrons flow from anode to cathode. Electrons flow from anode to cathode. So the current will flow from cathode to anode. Current will flow from cathode to anode. That is correct statement. Okay. Anode is positive. Yes. When you are talking about galvanic cell, when we are talking about galvanic cell, anode is positive, cathode is negative. No. One second. No. Anode is negative for galvanic cell. Anode is negative for galvanic. Yeah. Anode is negative for galvanic cell. Yes. Anode is negative for galvanic cell and cathode is positive for galvanic cell. For electrolytic cell, the concept is slightly different. For electrolytic cell, anode is positive and cathode is negative. Okay, that is a different kind of cell. Works totally opposite to this one. Okay, so this is incorrect. Okay, this is incorrect. If B is incorrect, this options eliminated. Correct answer is option C. B is incorrect, so these options are eliminated. Again, E not cell less than 0, it is a spontaneous. No, obviously. For spontaneous reaction, the E cell should be positive, E cell should be greater than 0, and the delta G should be less than 0. That means the Gibbs free energy should be negative and the cell potential should be positive. This is opposite, right? E cell is less than 0. Obviously, yes, Josh is really high. C, that is correct. This is incorrect. Again, cathode is a positive terminal, correct? Anode is a negative terminal. Okay, but here anode is positive written. Okay, so yes, A and D are correct. Correct answer is option C. Yo, Tukka trick, ma'am, very nice. Okay, Tukka trick, you want me a video? Okay, whenever if I have time, I'll make a video. Okay, this week if I have some time, I'll make the video. Okay. Okay, Megha, 48 you want me to repeat? Okay, I'll repeat it quickly. So, bacha, read the question once. When you bubble nitrogen gas through water, okay, how many moles would dissolve? How many moles would dissolve? Okay, partial pressure of nitrogen gas is given. We know partial pressure, this is according to Henry's law, bacha. This is according to Henry's law. What is according to Henry's law? That the partial pressure of that gas is directly proportional to the mole fraction of that gas. Okay, so partial pressure of any gas is directly proportional to the mole fraction of that gas. Okay, simple, very easy, right? If you replace the proportionality sign, we replace it with Henry's law constant. We substituted the value, calculated the mole fraction of nitrogen. Now we have the mole fraction of nitrogen. Okay, how can we relate mole fraction with number of moles? Mole fraction is number of moles of that component divided by the total number of moles, right? But since nitrogen amount is really less, and we have a really large amount of water, so we can just take the number of moles of water only. Okay, we ignore the number of moles of nitrogen. Okay, this value we know. This value, we have 1 liter of water. 1 liter of water has how much density? Normally 1 gram, 1 kilogram we take, whatever it is, per meter cube. Okay, so number of moles of, 1 second, what happened? Okay, Okay, so the number of moles of nitrogen will be equal to the mole fraction of nitrogen times the number of moles of water. What are the number of moles of water? 1 liter, 1 kilogram matlab. 1 kilogram means 1000 gram. 1000 upon 18, that is 55.55. 55.55 moles of water. Okay, we multiplied that. Okay, we get the number of moles of nitrogen, which is 7.16 times 10 raised to power minus 4. These are the number of moles of, yes, these are the number of moles of nitrogen. Okay, I know questions can be little trickier, but what are we doing? You remember that we are dissolving a gas in water. So we are dealing with Henry's law here. Okay, we are dealing with Henry's law here. Okay. Okay, I hope your doubt is answered. Okay, now we are going on to our next. Is this one we also done? Next question. Electronic conductance depends on. Harish, that is not fair. I just repeated it. I'll just repeat it once, okay? What is so different about this? Correct statement. Current flows from anode to cathode, cathode to anode. Electron flow in a galvanic cell, electron flows from anode to cathode. Current will flow in the opposite direction, that is from cathode to anode. Simple. Anode is positive terminal. No. Anode is negative terminal for galvanic cell. Cathode is positive terminal for galvanic cell. This is correct. E naught cell less than 0, spontaneous reaction. Nope. For a reaction to be spontaneous, E cell should be greater than 0 and the change in Gibbs free energy should be less than 0. Read your electrochemistry. I can't tell you there. Okay. Whole chapter I can't summarize. I can only tell you one portion. So the correct statement are option A and D. Okay. Okay, done. Next question. The electrolytic conductance. Conductance is the electronic conductance is basically the conductance by the ions that are present in a solution. Okay, depend on one normal solution we have, then it is equivalent conductance. If we have one molar solution, then it is molar conductance. Okay, so it depends on the number of valence electrons that are present. It depends on the number of valence electrons that are present per atom. Okay, it is directly proportional to the number of electrons present and inversely proportional to the temperature. Okay. Yes. Yes. So the correct answer is B. Okay. Electronic conductance will depend on the number of valence electrons. Okay. Next question. Yes, I think Josh is still high. I think for me also. Okay. Oh my God, Sharan, who is disturbing you? Please don't disturb Sharan especially. Girls, behave. Behave guys, behave. Why not C? Oh my God, why not C? Okay, let me see. Why not C? Concentration. Concentration. You see, concentration will only matter if you have a weak electrolyte and it is very high in concentration. You have a weak electrolyte, but it is very high in concentration. Will it give any valence electrons? Will it give any electrons? No, right? There will be no ions, no electrons. But if it is a strong electrolyte, even in dilute concentration, it will give electrons. It will give ions. Okay. So concentration is not directly related. The electrons are the major factor when we talk about electronic conductance. Conductance due to electrons. Okay. Yeah. Nature of electrolyte added. Yeah. No, electronic conductance, we are talking about electrons only. So the conductance due to electrons. Electrolytes normally have ions. Electrolyte conduct electricity using ions, not electrons. In electrons we have metals. Normally we deal with metals. Okay. Okay. Next question. Again, for this reaction you need to tell me the effect of increasing the aluminum concentration. What will be the effect of increasing the aluminum concentration on electrode potential? Okay, so tell me. Okay, you know this equation, E reduction. This is a half cell reaction, right? Reduction, half cell reaction. E naught reduction minus 0.059 by n number of electrons log of product upon reactant concentration. What is the product here? I'm just replacing it here. Product is Al, aluminum, upon Reactant is Al3 positive, Al3 positive. Okay, done. Okay, so now if I substitute N equals to 3, how many electrons are involved? 3 electrons. So it will be E naught cell. Okay, what is the aluminum? It's solid, right? What is the activity of aluminum? What is the activity of any solid or true liquid? That is 1. The activity is taken. 1, because their concentration do not change while we going through a reaction. They are solids, liquids. Okay, so in that case this is 1. So 1 by Al3 positive. I'm just writing it 0.059 by 3 log of 1 by Al3 positive. Now again basic laws, minus log of 1 minus log of Al3 positive, right? Log of m by n, log of m by n equals to log of m minus log of n. Basic maths, log of 1 is 0, so it doesn't matter. Minus log of Al3 positive. Now minus, and there is a minus outside, so minus will become plus. The equation becomes E naught cell plus 0.059 by 3 log of Al3 positive. That means this reduction potential, the cell potential, the electrode potential is directly proportional to aluminum ion concentration. It is directly proportional to aluminum ion concentration. Okay, directly proportional, right? So that means what? If you increase the aluminum ion concentration, the electrode potential will increase. If you increase the aluminum ion concentration, the electrode potential shall increase. Yes, correct answer is option D. Why? Because we just derived this relation. We just derived this relation. Okay, done. Next question. Faraday's law, very easy. Faraday's law. Okay, so when you convert Ag positive into Ag, how many electron we add? Only 1 electron, right? It gets converted into Ag. 1 electron. Okay, 1 electron. How much charge does 1 electron have? 1 Faraday. 1 electron have 1 Faraday. It's like not exactly 1, it is 1 mole of electrons, because we are converting 1 mole of Ag positive into Ag. We are converting 1 mole of Ag positive into Ag. And 1 mole of electrons have charge. How much? You remember it? 1 mole of electrons have charge 1 Faraday. 1 Faraday. 1 electron we are dealing, that means 1 Faraday. What is 1 Faraday? 96500 Coulomb. So that means this is the correct answer. A3. I don't even have to calculate for the rest. Mg2 positive needs how many electrons? Mg2 positive will require 2 electrons. That means again 2 mole of electrons. That means 2 Faraday. 2 Faraday means 2 times 96500. That is 193,000, right? Aluminum 3 positive, similarly aluminum 3 positive will require 3 electrons. That is your 3 Faraday. If you calculate it. And similarly titanium 4 positive will also need 4 electrons, which is 4 Faraday. That is titanium. So your answer will be this and this. Correct answer is option B. Correct answer is option B. Done? Okay. Okay, clear? Next question. Catalyst used to increase the rate of a chemical reaction. How do they increase the rate of a chemical reaction? What do catalysts exactly do? I am also tired. See, I am standing here. You at least sat and all. A for apple, B for ball. Wow. So tell me, Machas, whatever you call. Please give break, ma'am. Okay, we'll give you break. 7 more questions to go. Yes. So, increase the oxidation, proper orientation, increase. Yeah. The catalyst decrease. What do catalysts do? If the reaction was supposed to go by this pathway, what do catalysts do? If catalyst is there, they decrease the activation energy barrier. And now you'll need this concept in the next question. That's why I'm telling you, decrease the activation energy barrier. Okay? The activation energy decreased. Jai Janendra Rajesh, Jai Janendra. Yes. So, what do catalysts do? They decrease the activation energy of the reaction. Okay. Next question. Okay. Half-life of a first order reaction 20 seconds, initial concentration is this, concentration of reactant left after 80 seconds. So how many half-lives are possible in 80 seconds if one half-life is 20 seconds? How many half-lives are possible in 80 seconds if one half-life is 20 seconds? That means 4 half-lives are possible. 4 half-lives are possible, right? I'll just tell you one formula. If you want to calculate the concentration of reactant at n half-life, the concentration of reactant left at n half-life is equals to A naught, initial concentration of reactant divided by 2 raised to power n. N is the number of half-lives. N is the number of half-lives. Okay, so initial concentration is 0.2 by 2 raised to power 4, which is 0.0125 if you calculate it, option C. Firstly, we calculated the number of half-lives, which is 4, okay, and to calculate the amount of reactant left after n half-lives, the formula is A equals to A naught by 2 raised to power n. N is the number of half-lives, A naught is the initial concentration. Now this is the amount left after n half-lives, so that is 0.0125 for this case. Okay, done. It's a simple formula. N is the number of half-lives in this case. Okay, so we have how many half-lives? If one half-life is 20 seconds and you are given 80 seconds, so 4 half-lives have happened, right? Okay, so we have 4 half-lives. Okay, now in these 4 half-lives, what will be the amount of concentration that is left after these 4 half-lives? That will be equals to initial concentration divided by 2 raised to power n. What is n? N is the number of half-lives that has happened, which is 0.2 by 2 raised to power 4, which is 0.0125. This formula may be little bit new, but it's already been used for so long. Yes, we can use it for any. If we are given the half-life, that half-life is this much, okay, and we are given that this much time has passed, so this is applicable for all order reactions, okay. This formula is applicable because it tells about the amount of reactant that is left, so it is applicable for all order of reactions. Okay, next question. Okay, now for this reaction you need to tell me the activation energy for the reverse reaction. What is the activation energy for forward reaction? This much, right? What is the activation energy for backward reaction? This is the activation energy for forward reaction. And what is the activation energy for backward reaction? This much activation energy for backward reaction. Clear? So I need to calculate this. From graph also I can see this whole, if from this whole amount I subtract this amount, I will get this amount. If from this whole amount, I subtract this much amount, I will get the activation energy for backward reaction. This is the activation energy for forward reaction. The energy you need to raise the reactant to get the reaction happen. This is the energy you need to raise the product to get the reverse reaction happen. So activation energy of backward reaction will be 215 minus 90, which is 125 kilojoule. 125 kilojoule. Option A. Good. Good, Shaurya, Vijaya, everyone. Next question. For this reaction, you need to tell the rate of production of NO2. So I know from this relation only that rate of production of NO2. This is rate of disappearance of N2O5, because with the time what is happening, reactant is getting converted into product, so reactant concentration is decreasing. So the rate of disappearance, this is actually rate of reaction. This whole is the rate of reaction. This much, only this part, only this part is the rate of disappearance of reactant. Okay, this is equals to again, this whole is the rate of the reaction, okay, and only this part is the rate of appearance or rate of production of NO2. This is the rate of production of NO2. We need to find this value. We are given all the other values, okay. Now how will I calculate? I need this only. This whole thing, don't forget this T, this whole thing is rate of production of NO2. That is equals to what? If this 4 will go this side, right? 4 by 2 means 2. Change in concentration of N2O5. Initial concentration was 2.0. Okay, it is reduced to 1.4. Final concentration. Change in concentration is final concentration minus initial concentration. So minus 1.4 minus 2.0 upon the time is 300 minutes. 300 minutes. Okay, we don't need to change it because the answer is also asked in minutes. Okay, if I calculate it, what will be the answer for 56? What will be the answer? Tell me, calculation masters. Tell me. It will come out to be 4 times 10 raised to power minus 3. 4 times 10 raised to power minus 3. Clear? Yes, 4 times 10 raised to power minus 3. Good. Yes, good question. Good question, good answer skills. Next question. Which of the following is unitless? Unitless, we already know. Same unit up and down, numerator, denominator, unitless. Mole fraction. Where is mole fraction? Where is mole fraction? Mole fraction here, mole fraction here. This is unitless. Now let's see mass percentage. That means weight of the component divided by the weight of the solution. Mass percentage, right? Yeah. So again, weight by weight, this is also unitless. Unitless means have no units. Molality have units. Molar is the unit of molality. Okay? Yes, A. Next question. Incorrect statement again. 22 books have infinite significant figures. How many significant figures does 22 books have? Tell me. Yes. So 22 books have infinite significant figures. Yes, that is correct. 22 books have infinite significant figures. If no decimal is there are infinite significant figures. That is correct. We're looking for incorrect statement, macha. Okay. In the answer of calculation, 4 significant figures. Ayo, please solve it. Please solve it. I actually am begging you guys. At this point, I am too tired. But yeah. This have 2 significant figures, this has 3 significant figures. So the answer, if you do the product, if you do the division, if you do addition, or if you do subtraction, any of the operation you do, okay? So whenever you have 2-3 numbers in significant, you are given 2-3 numbers and you are performing these operations. So the answer will have the same number of significant figures as the least factor. So here one has 2, one has 3. So the answer will have the least number of significant figures. That means 2. The answer will have 2 significant figures, not 4. This applies to all of the operations. Multiplication, division, addition, subtraction. Okay. So this is incorrect. This is incorrect. In this case, this will be our correct answer actually. Okay. Now after that, zeros preceding to non-zero digits are significant. No, they are not. Zeros preceding to non-zero digits, are these significant? Nope, they are not significant at all. Okay, so that is also incorrect. In the answer of calculation, again 4 significant figure, 3 significant figure, 1, 2, 3, 4 significant figure. The answer will have how many significant figures? The answer will have 3 significant figures, and yes, that is a statement only. Yes. Yes, this is a previous year question. This is a previous year question. Okay. So the correct answer is, incorrect statement is B, C, and only B and C. B and C, which is option B. And all of you are answering option B. Good. Good. Okay. Okay. 59th question. I have already done this also, but I'll explain it. So we are talking about Dobereiner triads. Dobereiner triads means we are dealing with 3. What did Dobereiner said? What did Dobereiner said? Dobereiner said that he made triodes. He wrote 3 elements. Yes, he wrote 3 elements. He gave 3 elements in such a sequence that the atomic weight of the middle element is equals to the average of the atomic weight of the outer 2 elements. The atomic weight of the middle element is equals to the average of the atomic weight of the outer 2 elements. Okay, so in this case, I'll just save you the pain. Just calculate it. Okay, if you calculate the average of these to come out around 37.7 something, okay? But the potassium, for potassium the atomic weight is 39. So this is not a Dobereiner triad. This is not a Dobereiner triad. Yes, see. Last question. Are you ready? I am definitely not ready. Okay, I am ready. Hybridization is there. Answer. Just answer, please. Answer for this question, then we are done. Yes. Okay, so again, what is the change in hybridization? What is the hybridization here? AlCl3. So I'll tell you the formula, macha. The formula is this. Yes, half of number of valence electrons plus number of monovalent atoms minus cation charge plus the charge of anion. Half of, for AlCl3 I am calculating. For AlCl3 I am calculating, okay, half of valence electrons is 3 plus number of monovalent atom is also 3, 6 by 2, which is 3. 3 means steric number 3 means the hybridization is sp2. The hybridization is sp2. Okay, now look here. AlCl4 negative, half of number of valence electron of aluminum 3 plus how many monovalent atom? 4 chlorine, 4 minus 1. Minus means we add that plus 1. 7 plus 1, which is 8 by 2. Again, which is 4. 4 steric number means the hybridization is sp3. So the hybridization is changes from sp2 to sp3, and all of you answered option B. Thank you everyone actually for staying with me. I remember all of your names. Okay, Bro was there, Aniket was there, Asha was there, then there was Baslingappa was also there. Okay, Asha, Aniket, Solo was also there. Oh my god, thank you so much everyone for staying till 60th question. Take a screenshot again. I'm giving you space. Joe was also there. Yes, Bro is Joe. Oh, that is Joe. Okay, Arif, good. Yes. Oh, my throat is too dry, kya? It's okay. Yes, Harsh. Yes, Harsh, you were there. I know all of you were there, okay? I was just... Don't say that. It's okay. Joe, what happened? Don't do that, okay? My God, Aniket, you finished the whole class. Because I promised, Deepa, because I promised I will start from basic. Some of you are lacking in the basic, which is okay. Sometimes you can be reading about something and you don't know the basics sometimes, okay? Okay, let me just put it. Thank you so much. Thank you so much all. Thank you all for attending the class. It's a very long class. I know I could have started a little longer. Again, thank you for, sorry for the delay. I came a little late, okay? Yes. Okay. I am good. Thank you for asking, Solo. It's okay. Yeah. Okay. Done. Okay. Thank you, everyone. Okay. And if you did those questions on your own, right? Because I gave you some time, you did them on your own, claps to them. Okay. And please do mock tests, solve PYQs, do revision. That is very important, Macha. Very important. Okay. And yes, we will crack this KCET together. Don't worry. Okay. We got you. Everyone with, like, we all are here to support you. I am here to support you, okay? And any doubt you have, please mention them in the comments. I will answer your doubts, okay? Don't worry. And see you in the next class. Next class will be solving mock test, okay? So be ready. There will be new questions, different questions, totally new questions. Some maybe from PYQs and all, I don't know, but totally new questions will be there, okay? Yes, you should. It's me extreme. You should take the DPP or any test that is given there. You should take it after every class. Okay. Yes, there is evening class today, I think. Yeah. Okay, thank you so much. Wow, 4 hours. Even I don't know I spent 4 hours. Oh my god. Damn. Even I am in shock. Anyways, take care, machas. Take care. Lots of love and care to all. And please prepare. Okay. And take rest. Okay, go out for a walk, take care of your physical, mental health and all, okay? Take care. Tada, bye-bye. See you in the next class. Okay. Thank you.